Hello all, my name is Krishnayak and welcome to my YouTube channel. So guys, today in this particular video, we are going to see the entire deep learning project implementation from line to line. You will be seeing this entire implementation. This video has been made by one of my subscriber and student of iNeuron. His name is Bappy, and all his information will be given in the description of this particular video. The most amazing thing about this particular deep learning project is that this project name is called as face match project. That basically means it will try to compare your face with some celebrity and it will try to show it to you. Now, what is the most amazing thing about this particular project? This project will be completely implemented line by line from scratch. So this entire session will be somewhere around 3 hour session. And remember, in the description also I have actually given with respect to all the timestamps what all steps are basically included. And remember one thing guys, many people ask me about lot of end-to-end projects. So you can definitely take this as an example of an end-to-end project and implement in a similar way, because this is the implementation is completely in an object oriented programming manner. Okay, where we will be focusing on reusability of code and all. That is the main motto of iNeuron, like how we teach our students and subscribers, right? So I hope you enjoy this entire video. Please make sure that whenever you get time, watch this entire video. You will definitely love it and you'll see how the implementation will actually be done. So let's go ahead and let's see this entire project, and I hope you will enjoy this particular video.
Hello guys, my name is Bapi Ahmed, and today in this particular video, I'm going to implement an amazing project which would be based on deep learning. So in this video, I'm going to implement an end-to-end projects, okay, by using deep learning. So you can say it would be a deep learning projects, okay, and in this video, I'm going to show you the live implementation so that like you can go ahead with that and you can get the idea like how we can implement that projects. Okay. So we will use some different technique here, okay, for implementing that projects. I think you are going to like that, okay. So first of all, I will show you the demo of this projects, okay. So after seeing the demo, so we'll be implementing that projects, okay. So let me share my screen. So guys, the name of the project is to whom does your face match? Okay, so I think you have already probably seen some of the application. Okay, I think from your smartphone or from the website itself. Okay, so you have seen some of the application. If you put your image, okay, so it will tell you like to whom your face is matched. Okay, so yes, we are going to create similar kinds of application here. Okay, but in a different way, and I think you are going to like it, and you will also know like how you can also implement that projects. Okay, so after seeing the implementation you will realize how easy it is. Okay, so whenever we are using that kinds of application, okay, so you don't have to like confuse like how they have implemented. Okay, so here you can see this is the homepage of our projects. Okay, and you can see I have implemented this UI using this Streamlit. So if you don't know what is Streamlit is a you can say Python package. Okay, so by using Streamlit you can create amazing like you can say UI. Okay, and this live server also. Okay, so that like you can create any kinds of web application here. Okay, you can also use the Flask, but in this video I'm not going to use Flask. Okay, but if you are interested in Flask, so you can also implement it using the Flask one. Okay, so first of all I will show you some of the demonstration of this project. So see, if I browse here, okay, and if I select some of the images, suppose I have some of the images. Okay, I have some of the duplicate images. Okay, so I'm going to upload that and let's see how it is work. Okay, so first of all I will put one pic. Okay, so you can see this is a girl. Okay, she looks like almost Priyanka Chopra. Okay, so I have given to my model. Okay, now let's see what it is predicted. Okay, um, so it is predicting. See, it is telling she is Priyanka Chopra. Okay, so see, seems like Priyanka Chopra. Okay, so it is amazing, right? but she's not actually Priyanka Chopra, but she but her face is matched with you can say this Priyanka Chopra. Okay. Then if I put another image, so let's say I will put duplicate Shah Rukh Khan here. Okay, so let's see. So see, it is predicting and he's looking like Shah Rukh Khan. Okay, and let's say I'm going to give another pic. Let's say I'm going to give duplicate Salman Khan. So see, it is predicting he is looking like Salman Khan. Okay, and one of the challenging picture I'm going to give now. Okay, you can say I think you have seen this image. Okay, so there is a movie I don't remember, but in that movie, Amitabh Bachchan like you can say that kinds of makeup like he has taken. Okay, and see, it is also predicting he is Amitabh Bachchan here. Okay, so I think you were understanding how strong this model is. Okay, so here, and let's say I'm going to keep my peak here. Okay, so then see what it will predict. So see, I'm looking like Ritesh Deshmukh. Okay, it's fine. I don't know. I look like or not. Let's say I will give Krish sir picture here. So let's see what it predicts. So let me give. So I'm giving Krishna XR pics. Okay, so let's see. So you can see he's already looking like Amir Khan here. Okay, just do comment below. Okay, he's looking like Amir Khan or not. Okay, but guys, I think you are going to enjoy that projects. Okay, it would be an amazing projects. Okay, so I have shown you the demo. Okay, now let's implement that projects. So guys, first of all, we will download some images. Okay, from the Kaggle. Actually, in this projects, we are going to use this data set. Okay, for building our model. So here you can see this is the data set of Bollywood celebrity. Okay, so if you see that, so you can see the name of this data set is Bollywood celebrity localized face data set. Okay, so if you open up this data set, so you can see there are almost I think 8,000 images. Okay, you will get, and almost 100 Bollywood celebrities I mean images you can find. Okay, and those images like you can say those image size is like you can say this 64 into 64 pixel. Okay, like it is very small, but here like if you open up this data set. Okay, so if I open up this data set, so you will see this is just a face. Okay, so that this image pixel is very low. Okay, so here here we are going to use this you can say face recognition technique. Okay, face detection technique. So if our images is like low resolution, okay, I mean low pixel, I mean less pixel, so it doesn't matter. Okay, it will perform good at that time. So yes, so we are going to use that images. Okay, in our model, and you can see this is almost 27 MB. Okay, the size of this data. So here you will find a here you will find 100 Bollywood celebrities picture. So first of all, I will download this data in my local. So guys, you can see it is downloading. So I will wait. So guys, you can see I've downloaded this data. Okay, in my local. So if I go to my download section, so you will see this is the data I've downloaded. Now what I will do, I will just you can say create my project directory. Okay, so where I'm going to implement this projects. Okay, so for that suppose I'm going to create a you can say directory here. Okay, so I'm going to name it like you can say face you can say match. Okay, so you can give any name. Okay, it doesn't matter. So I have given face match. Okay, so if I go to this folder, and here what I will do, I will just copy my image. Okay, so here I will copy my image. So this is the data, this is the image. So from that this folder I'm going to move that here. Okay, then I'm going to like unzip this file. after unzipping this file, I'm going to delete that folder. This is not required, so you can get rid of that. And so yes, this is the, you can save my data. Okay, so if you see, this is the data I have. So if you go to this folder, so you will see there are 3 folders, okay, here presented. So if you click on that, so you will see all the, you can say, Bollywood celebrity names here. Okay, so if you click on that, okay, so you will see all the picture, okay, of this celebrity face. Okay, so you can see this is Amir Khan. Okay, and if I open this picture, so you can see this is a very small picture, because this resolution is like 64 into 64. Okay, so that's why, but that is fine, because we will be using this face, you can say, recognition technique here. Okay, so the resolution is fine as of now. So yes, like that, there are, you can say, almost 1000, so like that, you can see there are almost 100 celebrities picture there. Okay, so so now what I'm going to create another folder. Okay, so I'm going to name it like data. Okay, after creating this data folder, I will just go to this folder, and I will copy, you can say, I will move all the folders, okay, all this celebrity folder in a one folder. Okay, so like I have moved that. Okay, I have, you can say, selected, and I have pasted it here. Okay, so yeah, you can say this first folder, like I have moved all the file. Then like that, I will just go to this second folder, and I will cut all the file, and I will go to my data folder, and I will paste it over there. Okay, like I think you are getting, like I'm just trying to, you can say, bringing all the data, okay, in a one place, so that like I can read it very easily. Okay, so that is what I'm doing here. Then similarly, I will go this third folder, then I will move all the file, uh, and I will paste it over there. Okay, so guys, you can see I have moved all the file here. Okay, so you can see there are almost 100 Bollywood celebrities data I have. And now what I'm going to do, I'm going to just get rid of this file. Okay, that is not required. And this is my, you can say, this actual data I'm going to use in my model. Okay, so yes, we have done our, you can say, first step, okay, of our projects. Now what I'm going to do, I'm going to just briefly tell you what would be our architecture. Okay, so how we are going to implement that projects, okay, end to end. So for that, I'm going to open up my whiteboard. Okay, so here you will see it's a VGC face architecture. Okay, so if you don't know, VGC face is a model. Okay, so you can use that for extracting feature. Okay, and you can also use that, you can say, this algorithm, you can say, for detecting gender, then hair color, okay, then age, then facial, and also this facial hairstyle, then age. Okay, so you can you can say detect, okay, by using that algorithm. So here we are going to use, you can say, this algorithm, okay, in our you can say projects. Okay, but why we are going to use this VGG face? Okay, because first of all, like here we have our images. Okay, like we have the face of all the celebrities. Okay, in, I mean, if I talk about in my folder. Okay, so what I'm going to do, I'm going to extract some of the feature from the, you can say, images. Okay, so I think you have you already know about the CNN. Okay, so in CNN, what we do, we just try to, you can say, extract the feature. Okay, so by using these kinds of, you can say, CNN architecture, or you can say this various model. Okay, we can use that, but in this projects. Okay, so because we are, you can say, we are working with the face. Okay, so that's why we're using this architecture, because it has already been trained on, you can say, this face data set. Okay, so that's why we're going to use this VGG16. Okay, so if I talk about briefly, okay, so you can see there are two part. Okay, so if I you can say, make a border. Okay, so you can see it's a, you can say, flattened and dense layer. Okay, so I think you know that. And if I talk about, this is the pure CNN part. Okay, so we can use this part, okay, by extracting the feature from our images, okay. And we can get rid of this part because this is not required, because we are not going to, you can say, identify this gender or hair color, okay, all the thing. So we can, you can say, get rid of that, and we can keep this, you can say, architecture for extracting the feature from the image itself, okay. So I think you got the idea now what I'm going to do, okay. So that's why I'm going to use this, you can say, convolutional network, okay. So that name is VGZ face, okay. So there are also some of, you can say, facial extractor, okay. You can say over the internet, so you can also use that, but in this projects I'm going to use that one. And so that was like our, you can say, model architecture, okay. So we're going to use, now I'm going to tell you, now I'm going to briefly tell you about our architecture, okay. So how we can, we are going to implement that projects, okay. So if I talk about the architecture of this projects, okay. So first of all, like we are using here this, you can say, this VGZ, okay, VGZ face, okay. So VGZ means like visual geometry group, okay. It is from Oxford, you can say, university, okay. So there is a group called VGZ geometry group, okay. So they have developed this, you can say, algorithm, okay. So this VGZ, okay. So the the meaning of this VG is visual geometry group, okay. So we are using that algorithm in our, we can say, projects, okay. Then the architecture wise, like we will be like create our own architecture, okay. So like that we'll write all the code, okay. So so here, I think you have already seen, we have downloaded, you can say, 100 Bollywood celebrity images, okay. And I guess there are almost 8,000 data, okay, 8,000 images in your folder, okay, we are going to utilize. So from this 8,000, you can see, images, okay, we are going to first of all resize the images, because you have already seen this is 64 into 64, okay, 64 into 64. But if you have already learned this, you can say, this VGZ, okay, you can say VGZ algorithm, so you will see it will take the image size like 2 to 4, okay, 2 to 4. Sorry for my bad handwriting, actually I'm using my mouse, so let me clean. Okay, so it takes 2 to 4 times 2 to 4, okay. So it will take your image resolution like 2 to 4 times 2 to 4, okay. So that's why we have already this 64 into 64, okay, resolution images, okay. Then from this 64 into 64 we will convert it to 2 to 4 into 2 to 4, okay. So so our architecture would be like, suppose I'm getting the images, okay, from my, you can say, directory, and you can say from my folder. Then I will just resize it in 2 to 4 times 2 to 4. Then I will pass these images to my model, okay. So suppose I'm passing these images to my model, and after passing, this model will return, okay, this model will return an array, okay. That would be, so if I pass these images into my model, so that will give me a, you can say, a 2D array, okay. So in this 2D array, you can say, here we know we have 8,000 images, okay. So so each images there will be an 1D array, okay. So 1D array means like there would be, you can say, 20 2048 item, okay, 2048 item in each array, okay. So I think you get the idea, okay. Suppose we are using this VGZ face here, okay. So if you already know, so if you use this VGZ, you can say, face, you can say, CNN, you can say, convolutional neural network here, okay. So it will give you the feature list as a 2048, you can say, number of array, okay. So in so each array will contain 2048 items, okay. Like that we have, you can say, 8,000 images, so we will get, okay, we'll get 8,000 array, okay, 8,000 array in this feature list, okay, 2048. And each array will contain 2048 number of, you can say, items, okay. So I think you got the idea, okay. So this is a 2D array. Now we have a 2D array, and this in this 2D array we have you can say 8,000 number of you can say images, okay, and this image has been converted to a you can say 1D array, and each array will contain 2048 items, okay. So I think you got the intuition what I'm trying to say, okay. And you can also call it as a vector, okay. It's a vector, okay, it's a vector. Now what I'm going to do, so I got you can say this so I got the vector, okay. So now I have now I have the vector, so okay. So from this vector now I will do the prediction, okay. So for the prediction part what I will do, so this is the prediction part, prediction. So in this prediction part we will create and we will create an we will create a web app, okay. We'll create a web app, then here would be a you can say button, okay. So by using that button we can upload an image, okay, and this image we will save in our local, okay. So we will save in our local, and this image will convert it to 2 to 4 times 2 to 4, okay, because we have already you can say taken this images to 2 to 4 into 2 to 4, okay. So that's why whenever user will upload one image, okay, at that time we will also apply the similar task over there, okay. Then from that I will pass these images to my model, to my VGG face model. So it will return an 1D array, you can say it will return an 1D array. It will contain 2048 number of items, okay. So now we have now we have another vector, okay. So this is our new vector, okay, we have got from the user. So and we also have our previous all the vector, okay, like all the images, okay, we have converted to the vector. Now what I'm going to do for the prediction itself, so now what we will do, we'll just measure the cosine similarity between these you can say vectors, okay. So so by applying this cosine similarity we will get to know like from which vector, okay, this new vector I mean this similarities I mean you can say more high, okay. By that we will get to know, yes, this is the vector, okay, this new vector is you can say similarity is high. Then we will select those vector as a you can say recommended you can say images, okay. So what I'm trying to say, I will just draw that, okay. So for that, like first see we have 2048, okay, you can say items, okay, in a vector. So if we create 2048 dimension here, okay, so if we create 2048 dimension, suppose this is a 2048 dimension and we have all the point, okay. So these are the point, you can say 2048 point in this dimension, okay. We have suppose this is the new data, okay, this is the new vector user has you can say user has given. So suppose this vector is here, okay, this is here. Now what we will do, we'll just measure the distance, okay, measure the distance from all the data points, okay. So see, we'll measure the distance from all the data points are presented in this you can say axis, okay. Like that here we'll find the distance between these you can say vectors, and like that we'll get to know what is the less distance here, okay. So whatever we're getting the less distance, okay, so we'll like you can say so we'll consider, okay, so this data point is belong to this you can say this category of the vectors, okay, this category of the images, okay. Like that we will select you can say those images, okay, which is similar and which is like less distance, okay, with this you can say all the data points we have, okay. Now I think you got the idea like how we are going to implement that, okay. So whatever I have covered till now, okay, I will give a short summary, okay. So if I explain it, first of all, so we will use this VGG face, okay, for extracting the feature, and this VGG face, okay, and we have you can say a and 100 Bollywood celebrity images, okay, and almost we have you can say 8,000 images, okay. And so from this 8,000 images, first of all we will take one by one and we will convert it to 224 into 224, because this VGG takes, you can say, input size as a 224 into 224. Okay, then I will pass these images to my model. Okay, then this model will give me an 2D array. Okay, 2D array. So 2D array means like it will contain 8,000 images. Okay, with this 1D array. Okay, you can say, and this 2D array will contain this, you can say, 1D array. Okay, so each array will contain 2048 values. Okay, so you can say, also you can also call it vector. And if we have the vector, then we will just save it, okay, in a pickle format, so that we can use it later. Okay, then during the prediction we will use this vector, okay, for measuring the cosine similarity between the new vector with this old one. Okay, so for the prediction itself, like we will create a web app, and whenever user will, you can say, put an images. Okay, then we'll also convert it to 224 into 224, then we'll pass it to the model, and this model will give me another array, which would be a 1D array, which will contain 2048 number of features. Okay, and this we have these new features, and we have this, you can say, feature list here. Okay, so then what we will do, we'll just calculate the cosine similarity. Okay, we'll just calculate this, you can say, cosine. Okay, cosine similarity we'll calculate, and whatever like similarity would be, like, you can say, high. Okay, we will select this, you can say, images as our recommended images. Okay, so this is the workflow of our, you can say, entire projects. Okay, I think you have got the idea. Now let's implement that projects. So guys, now we are going to start the coding part. Okay, so first of all, like we have already created our project directory here. Okay, and we have, like, you can say, moved our data set in our project directory. Okay, now let me open up my VS Code here. So in this projects I'm using VS Code. Okay, so you can also use PyCharm. Okay, so it's up to you, but but I prefer this VS Code, so that's why I'm going to use this VS Code. Okay, so yes, I have opened this VS Code here. Okay, now let me open up my terminal. Okay, so first of all, let me tell you, actually I'm using the bash terminal here. Okay, so you can also use this, you can say, anaconda. So you can also use, you can say, PowerShell or anaconda terminal here. Okay, so you can change the terminal from here itself, but as of now I'm using the bash, you can say, terminal here. Yes, I have opened up my terminal. So first of all, I'm going to create an environment here. So I'm going to create a virtual environment here. Okay, so for that, you can also create this virtual environment in your, you can say, C drive. Okay, but I have seen one problem. Okay, so whenever you are creating the virtual environment in your C drive, okay, so it is getting full. So that's why, like, we will use different technique for creating the virtual environment. Okay, so we will create this virtual environment in our project directory itself. Okay, so there is a command for that, so you can use. So I will write conda create hyphen, you can say, prefix, um, hyphen prefix. Then we'll name our environment. Okay, so it would be env. After giving env, we have to define our Python version. Okay, so we are going to use this Python equal to 3.7 here. Okay, 3.7 is fine. Then we will give hyphen y. So why we're giving this minus y, because we're allowing to create this, you can say, conda environment in a one time. Okay, so if I hit enter, so you will see it will create a virtual environment in our project directory itself. Okay, so yeah, it will take some time to create. Okay, so we will wait. So guys, you can see this environment has been created. Okay, so you can see this is the folder has been generated. So this is the same. Okay, so whenever you create any kinds of virtual environment in your, you can say, C drive. Okay, so you will see all the necessary file would be there. Okay, but we are created in our project directory itself. Okay, so that, like, it will not take your, you can see, space of your C drive. Okay, So yes, we have created our virtual environment. Now we will activate the environment. For that, like, you can write conda activate conda activate dot and this forward slash. Okay, then you will write e. Then if you press tab here, okay, so it will get autocomplete. Then if you hit enter, okay, so you will see this environment has been activated. Okay, so if I clear my terminal, so you can see, here you will see this is here you will see it has activated this env. I mean, you can say this environment. Okay, but for you, it might be a big name. Okay, like it might be a folder location here. Okay, so that is fine, because I have configured it with a small name. Okay, so for you it might be different. Okay, so it doesn't matter. So yes, we have configured our you can say environment. Okay, now what we will do, we'll create some of necessary file. Okay, like this file we are going to utilize in our projects. Okay, so first of all, we will create a file which would be our requirement.txt file. Okay, so in this requirement.txt file, we'll mention all the packages, okay, which are whatever we are going to use in this projects. Okay, so for that, like I'm going to create one file. Okay, so which is requirement.txt. Okay, so for that I'm going to like write touch. Okay, touch, then I will just write require mains.txt. Okay, so touch is a, you can say, bash command. Okay, so because I'm using this bash terminal here, so that's why I'm using this touch command. Otherwise, like, you can also create any kinds of file or folder by using this, you can say, button here. Okay, so you can easily create. Otherwise, like, you can create it manually. Okay, so it's up to you, but I'm using the bash terminal here, so that's why I'm using that command. Okay, so if I now hit enter, so you will see there would be a file called requirement.txt. So I will open that file, and then I will mention all the necessary packages whatever we are going to use. Okay, mm. So first of all, I'm going to use this empty cnn. Okay, so why I'm using this empty cnn, first of all, let me tell you what is empty cnn. Okay, so if I talk about this empty cnn is nothing but it's a face detection and alignment, you can say, algorithm. Okay, and so we can use that. Okay, so the full name of this empty cnn is multitask, you can say, cascade convolutional neural network. Okay, by using this empty cnn, we can, you can say, detect the face. Okay, you can say from an images, or you can say from video, you can say frame. Okay, so we can detect our face. Okay, so you can see face recognition is the problem of identification of verifying the people in a photograph, okay, by their faces. But we can do that by using this empty cnn. Okay, it's an you can say algorithm. And here this is the paper link also. Okay, so you can also read this, you can also read about this empty cnn. So I will give the link in the description. Okay, so that, like, you can go through that paper. Okay, so how it is working, how it is detecting the face. Okay, and there is also a blog. Okay, so like how does a face detection program work. Okay, so you can also read out that. Okay, because I'm not going to explain how the face recognition work in this video. Okay, so if you want to learn more, so you can like refer these two links. Okay, I'm going to give these two links in the description. Okay, so if I show you some of the demo, so yes, see, this is the demo. So if you give any picture, okay, so it will detect the face. Okay, actually I have forgot to say one thing. Okay, in this architecture itself. Okay, so if I tell you that, so see, whenever we are you can say taking an images from the user. Okay, so it might be full images also, okay, of the user. Suppose it might not a face. Okay, so at the time we have to detect the face from the images. Okay, so like for that, so first of all, whenever we are taking the images from the user, okay, and first of all, whenever we are saving that, okay, so what we'll do, we'll just, you can say, take this image. Okay, then we'll just apply this empty cnn on top of that. Okay, empty cnn on top of that. So empty cnn will pass the face. Okay, the face of the images. Okay, so suppose this is the images. Okay, there is a person, and this is the face. Okay, so suppose it has detected, and it will just give me this coordinate. Okay, this bounding box coordinate here. So we'll get the face of these images at the time. Okay, then we will take this image. Okay, we'll take this just of the face. We'll just take this face. Okay, instead of the whole body, we'll just take this face and we'll pass it to my next, you can say, step, okay, where we will just, you can say, resize the images to you can say this 24 24, that 224 224, then we'll just pass it to our model, then it will extract the feature, okay, then it will generate the vector, okay. So this is the architecture we're going to use, okay. So for that, like, we are going to use this mtcnn, okay. So I think now you have the idea why we're going to use this mtcnn, okay. So for that, I'm going to use this mtcnn version wise. I'm going to use this you can say 0.0.1 0.1.0. Then I'm also going to use TensorFlow. Although this mtcnn uses okay, TensorFlow in the backend, but we're also, you can say, install our, you can say, TensorFlow version 2, okay. Here we are going to use, so that, like, I'm going to use this 2.3 point, you can say, 1. And also, like, we're going to use keras, you can say, keras wise, like, we will use 2.4 point, you can say 3. And sorry, there would be double equal. And we are also going to use this keras vcc face, okay. So this vcc face is in the keras, okay, so you can use that directly. Keras, you can say, hyphen, then vgc face, okay. So this is the, you can say, algorithm we're going to use for extracting the feature. So the version itself, I'm going to use the 0.6. And also we are going to use this keras application, keras, then underscore application, version wise, I'm going to use 1.0.8, okay. Then also I'm going to use this py.yaml, because I'm going to use the YAML file here, so that's why py.yaml. But then I don't need any version for that. And also I'm going to use tqdm. Why I'm using this tqdm, I will tell you. Tqdm, then I'm going to use sorry, I'm going to use sklearn here also, scikit-learn, sci scikit-learn. Then I'm going to use this, you can see, streamlit here, okay. Streamlit, I've already told what is streamlit, okay. So by using streamlit is a package, by using you can create and you can say web UI or web app, okay. So I'm going to use this streamlit, okay. Then also I will install another, you can say, package, which is a bing, you can say, image downloader, okay. So we will use that image downloader, okay, being in image downloader. And yes, these are the, you can say, packages, okay, we will use. And let me create another file, okay, so which is setup.py, because we'll create some of the, you can say, local packages here, okay, so that we can utilize you can see in our projects, okay. So I'm not going to publish it as a package, but I'm going to create some local packages, okay, for these projects, okay. So that, like, I can, like, you can say, create some of the folder, and I can keep some of the utility file in the folder, then I can use that, okay. So for that, I'm going to create a setup file, okay. So I'm going to write just touch, then setup dot py, okay. So if I write that, then I will just open it up. Then whatever necessary, I will just write it. So here I'm going to use this setup tool, okay. So from setup tool, setup tools, import setup, okay. uh, then setup wise, like, setup echo setup, then First of all, the name of the package would be src. Okay, src, because whatever folder I'm going to create, okay, so the folder name would be src. Then this is the name of my package. Then I will define the version of the, you can say, package. Okay, so version wise, like I will mention it, suppose let's say 0.0.1. Okay, then also, like, I will define the author. Okay, so here you can mention your name, because I'm going to use my name here because I'm implementing right now. So Papi Ahmed. Okay, so you can mention the author. And okay, let me define in a double quotation, that would be good. Then I'm going to like define the description of this, you can say, package. So I can write, you can say, a small package for uh, so I'm going to like define our project name here. Like, our project name is to whom um, your to him does your uh, face match. Okay, so this is the description. Okay, so you can write long description here. Okay, it doesn't matter. Then also you can define URL here. Okay, so suppose if you have any URL of this projects, okay, so you can also define here, but I'm not going to use the URL here. Then I will define the author email. Okay, so author email wise, I will define my email here. You can also use your email, 7 to 3. Then what is our package directory? So we have to mention that. So package wise, like packages equal to, like, there would be a folder called src. Okay, so yes, this would be my package folder. And the python requires up to 3.7. Okay, so you can use up to 3.7. And the install package, okay, install requires, you can mention. Okay, so whatever the install requires, you can mention here. So whatever you have written here, okay, all the things, just copy that and just, you can say, paste it over there. Okay, then just define it in a, you can say, quotation. So yes, I have written all the, you can say, required packages here. Okay, now what I'm going to do, okay, so there should be setup, not setup tools. Okay, there should be setup. Now what I'm going to do, in this requirement.txt file, I'm going to just write you can say I mean, just one line. So this is for local package. Okay, local package, so hyphen e, then dot. Okay, So what it will do, okay, so whatever we have like written here, okay, so our local package, okay, so it will create a local package for us, okay. Suppose here we are going to create an src file, okay, and in that src file we will keep all the utility tools, okay. And yeah, and whenever I'm mentioning the -e over there, okay, so it will install whatever we have written here, okay, automatically install that. So now what I'm going to do, from the terminal itself, I'm going to just install all our requirement.txt, okay. So first of all, let me create this src folder, okay, then I will just install all the packages, okay. So for that, like, I will just write touch dot not touch, okay, because we are going to create a folder, so that's why I'm going to use mkdir, okay, mkdir. Then we're going to name it src, okay, src. If I hit enter, so you will see there will be a folder called src. And so src is a package, okay. So for that, like, we have to create another file, okay, which would be underscore underscore init underscore underscore dot py. Okay, so I think you already know about the package, okay. So if you open up any package, okay, so you will see one file that would be underscore underscore init underscore underscore dot py, okay. So it's a, you can say, package, you can say file, okay, initialization file, okay, if you open up any package. So I will just create that. So for that, like, I will just write touch, then where I'm going to create that file into src, then I'm going to name it like underscore underscore init underscore underscore dot py, okay, dot py. And if I hit enter, so if you open up this src, so you will see that file. And this src and in this src folder, I'm going to create another, you can say, folder, which would be utils, okay, because all the utility I'm going to, like, create in this util, you can say, folder, okay. And all the steps we're going to perform, we're going to keep this that in our src folder, okay. So like that, I'm going to create another file, which is mkdir, where I'm going to create it in our src, okay, src folder. Then I'm going to name it utils, okay, utils, okay. This is the name of the folder I'm going to create. So if you open up this src, okay, so let me show it manually. So if I open up this src folder, so you will see another, there is a file called underscore underscore init, and there is also a folder called utils, okay. And in this utils, because utils also should be a package, okay. So in this utils, we are also going to create another init, you can say, dot py, because it would be another package, okay. So for that, like, I'm going to just write touch, then into src, then into utils, I'm going to create underscore underscore init underscore underscore dot py, okay. So if I hit enter, so if I open up that, so you will see there would be another, you can say, python file, which is underscore underscore init dot underscore underscore dot py, okay. So yes, so we have done our, you can say, this you can say, package folder, okay, we have already created. Now what I'm going to do now, I have already told you, I will keep all the utility, okay, utility files in our utils folder, okay. Utility files means whatever function we will be using, okay, you can say, repetitively. So we'll make a function, okay, in this utility, you can say, folder, okay. Okay, then we will use those utility function, okay, use the necessary function in our project, okay. So that's why we have created this utility folder here, okay. So like, I will create another file, python file here, okay, that would be name of all utilities, okay, all utils, okay, because this in all utils python file will be creating all the function, necessary function, okay. So for that, I will write touch src, then into utils we will create another file, which is all underscore utils, okay, utils dot py, okay. So if I hit enter, so if you see, you already see, you can see all the utility, you can say, okay, so this all utility folder has been created. Okay, now we can open that file and we can write all the necessary function here. Okay, so I will show you what I'm trying to say. As of now you might get some kinds of confused, but after creating all this, you can say, process, okay, so you will get to know why I'm doing that. Okay, now let me install this, you can say, packages in our local environment. So for that I will use one command. It's pip install, okay, -r. Then I will just write requirement.txt. okay, requirement.txt. So if you hit enter, so you will see all the necessary packages will be installing. Okay, so guys, you can see it is installing, but first of all I got an error because here I have mentioned one comma into this TensorFlow, you can say, name. Now I have fixed that. Okay, so now we can see all the necessary package is being installed. Okay, so we'll wait until it has been installed. Okay, so guys, as you have already seen, I have installed all the necessary packages. Okay, so yeah, you can also do that. So now what I'm going to do, I'm going to create, you can say, some of the necessary file. Okay, which we will be utilizing here. So first of all I'm going to create one file here. So okay, so which would be like, you can say, parameter.yml. okay, so why we're creating this parameter.yml file? Okay, so I will tell you whenever we will be creating our model. Okay, so for that, like, I will give a command, so which would be touch dot touch parameters. So I will write params, params dot yaml. Okay, so yeah, as you can see, I have already created this params dot url. So let me clear my terminal, and I will also create another folder here, which would the folder would be like config folder. Okay, so let me create mkdir config. So if I hit enter, so you will see there would be a folder called config. Okay, so in this config folder I will create another, you can say, YAML file. I'm going to name it file, you can say, config.yml. so for that, like, I will write touch, then in the config folder I will create another file called config.yaml. So guys, you can see I have created this YAML file here. Okay, so yes, we have done our, you can say, all the, you can say this necessary folder I have created. Now what I'm going to do, I'm going to this open up this all utils, you can say, folder here. Okay, and in this all utils folder I'm going to, like, write all the necessary, you can say, repetitive function, which would be like, we are going to utilize in our, you can say, entire projects. Okay, so for that, like, I'm going to import some of the package. So import wes, not wes, first of all I will import yaml, then next I will import wes, sorry, operating system module. Then also I'm going to import the logging, because I'm going to save all the logs, okay, whatever we are generating. Then here, like, we'll create a first function, which would be like, it will read our YAML file. Okay, so in this YAML file, okay, we'll be giving all the, you can say, necessary folder path or file location. Okay, so by using that we can read all the file location and folder path. Okay, and we can easily, like, you can say, navigate through our entire projects. Okay, so that's why we're creating this config .yaml file here. Okay, so I will tell you whatever I'm doing. Just just stay with me. Okay, just let me write. So for that I'm going to define a function. Okay, so this function I'm going to name it read YAML. Okay, read YAML, it will read the YAML file. So here I will define the path to our YAML file. Okay, we are going to give, and that should be a string. Okay, so that's why we'll just mention it. It is a string. Okay, and for after that it will return, you can say, a dictionary here. Okay, so like that's why like we'll mention it a dictionary. Whatever I have written, I think you are getting, like this function will take an you can say path location. Okay, it would be a string, and it will return a dictionary format output. Okay, so that's why we have defined this dict. Okay, otherwise you can also get rid of that. Okay, it is not necessary, but I have like you can say mention it over there. Okay, now we're going to open our YAML file with this open you can say function. Now I'm going to define the path. Okay, so in the you can say path, so this is not necessary, path is fine. And then you can say as YAML file, then content YAML.load. We are going to use this you can say safe load here, safe load, safe underscore load. Okay, so yeah, for reading this YAML file we will be use this safe, you can say safe underscore load. Okay, then we'll pass the YAML here. Then for that, like I will return the content, return this content. It is showing some error. Okay, so I don't have to define that clone here. Okay, now yeah, I have written this function. Okay, so by using this function we can say read any kinds of YAML file. Okay, then I will create another function which will create our directory. Okay, so suppose I need a directory here. Okay, so I need to create it. So by using that function we can create any kinds of directory here. Okay, so for that, like I'm going to name it create directory. Okay, create directory, and it will take you can say it will take you can say directory, you can say name. Okay, whatever name you are going to create, so it will take this name, and it would be a list, because why I'm giving the list here, because if you want to create you can say a multiple directory in a one shot. Okay, so you can also create that. Okay, so that's why you have to pass the list of the name. Okay, so that's why we're taking the list here. Okay, and then we'll just iterate through this list. Okay, so for dir underscore path in dirs. Okay, then we'll just create the directory west.make dirs, then our dir path, and then we'll also define a parameter here that is exist. Okay, is equal to true. Okay, so if it is exist, so it will not create that, otherwise it will create. Okay, then I will just log the information here. Okay, so logging, then dot info. Okay, so I'm going to logging the information, like you can see the log here. So I will just you can say name it, I will use this app string here. Okay, then directory is created at okay, so at our location dir path, dir underscore path. Okay, so yes, I have done our second function. Then yes, these are the function as of now we need to like create. Now what we will do, we will be creating our you can say main, you can say stage. Okay, so whatever we have explained in our architecture. Okay, so we'll be creating all the, you can say function and all the files. Okay, so let me do that. So guys, now I'm going to create our you can say first stage. Okay, so of our projects. Okay, so for that, like, I'm going to create a Python file in our src folder. Okay, so if you minimize that, so you can see in the src folder there is just one file, which is underscore init.py. Okay, and in this src file we will create our first instance. Okay, so like that, like, we'll just write touch. Okay, touch, then we'll just, this is our first instance, so that's why we'll be like name it 01. Then we'll give the name like generate image pickle. Okay, pickle. So why I have named it? Okay, so you can name it any name, but okay, sorry, actually I have created it here. Okay, outside of the folder. Let me move it to this you can say src. Okay, so for that there is a command mb. Otherwise, like, you can manually move that. Okay, you can manually just cut that and just paste it over the ssc, but I'm going to use this terminal. So mb this you can say 01. Okay, then I'm going to move it in the src folder. Okay, src mb this 01. So I have moved it to the src. Okay, so if you open up that, so you can see I have moved it in the src folder. So why I have created this file? Okay, so let me tell it about. Okay, so I have already told. Okay, what would be our architecture. Okay, so if I show you, first of all, like, because we have 8,000 images. Okay, we have 8,000 images. uh, okay, so 8,000 images, and we can say we have 100 Bollywood celebrities, you can say, photos. Okay, so we have in our data folder. Okay, so what we need to do, first of all, we need to like read all the images. Okay, all the images. Suppose this is Amir Khan. Okay, this is Amir Khan. So if I open up my folder, so this is the data folder. Suppose if I open this folder, so suppose this is Amir Khan, and in that Amir Khan, okay, so you will see all the picture of Amir Khan. Okay, so what I'm going to do, I'm going to read all the path. Okay, all the path of these images. Okay, suppose what would be my path? Suppose data, then slash Amir Khan, then slash this Amir dot 40 jpg. Okay, then Amir 41 jpg. Okay, that's how, like, there is a path. Okay, so I'm going to read those path and I'm going to save it in a pickle format, so that, like, I can utilize that in the later stages. Okay, because I don't want to, like, you can say, because if I read it one time, okay, so if I save it the location, okay, so I don't need the data, because uh, why? Because I have already the, you can say, path of the images. Okay, so I don't need the data, and I don't need to read the data again and again. Okay, so that's why I'm going to use this you can say pickle format. I'm going to save it pickle format. Okay, otherwise, like, you can keep it raw. Okay, it is fine, but here I'm going to save it in a pickle format. Okay, so that, like, I can read and write more quickly. Okay, so I think you got the idea what I'm going to do. So first of all, like, I'm going to open up my this generate pickle file. Then after that, like, before that, I will just configure my configuration.yaml. Okay, so whatever the necessary path, okay, whatever necessary directory I'm going to use in this projects, okay, I will mention each and everything here. Okay, so here, this is a YAML file. So if you know how to write YAML file, so that's fine. Otherwise, like, you can get the idea from here. So first of all, I'm going to define a key that is artifacts. Artifacts, you can give any name, but here I'm using the artifacts because every project, you can see there, they'll be using this artifacts. Okay, it's a common name. Artifacts means, like, whatever you are generating. Okay, so it would be inside there. Okay, so that's why I'm just name it artifacts. Okay, so inside the artifacts, I will create artifacts directory. Okay, so artifacts underscore dir. Then I'm going to name it artifacts. Then our pickle format data dir, pickle underscore format, then underscore you can say data dir. The folder name would be same. Okay, pickle format data. Okay, so you can give any folder name. Okay, it's fine. So I'm going to use that. Then image pickle file name. Okay, so image pickle file, you can say name, I'm going to name it image underscore pickle underscore file dot pkl. Okay, pickle format I'm going to use. Sorry, that should be pickle image file pickle name pkle. Okay, that should be pickle. Why I have created this you can say file here, because in this artifacts folder, okay, so if I run that, so in so it will generate an artifacts folder here. Okay, so in this artifacts folder it will create another folder named pickle format data. Okay, in this pickle format data there will be like saving our all the file location, okay, all the image location in a pickle file, which should be image pickle file dot pickle. Okay, so that's why we have created that. Now what I'm going to do now, I'm going to use our feature structure extractor. Okay, so what is feature extractor? I will tell you later, but first of all, like I need to create it. Okay, so extractor or though like we can name it extraction dir. Okay, so in this special extraction dir we can create a folder called extracted feature. Okay, then we can also because why we have created this feature extraction dir, suppose I have already told. Okay, so if I go there, I have already told what we need to do. We are just reading all the images. Okay, then we will convert it to 224 format, I mean pixel. Then we will give the model, and this model will output an 2D array. Okay, 2D array means it will contain 1D I mean containing 20448 array. Okay, and we are going to save it this array. Okay, we are going to save it this array in a pickle format, because we will be using this pickle format. Okay, so that like we need to like keep the data set always in our directory. Okay, because if we just read the data like again and again, okay, it will take more time. Instead of like we if we just create one pickle file, and if we can read one time, okay, so our job would be like more fast. Okay, so that's why we're converting it to this, you can say pickle format. Yes, so yes, you can say I'm using this pickle format. Okay, so when I will be implementing, so you will get the idea why I'm doing that. Okay, so for that, and here you can also you can say also name it, okay, embedding, because you are saving the array at the end. Okay, so you can also call it embedding. Okay, so I will just call it in embedding pickle file. Okay, so if I just name it extracted features name, so I'll just name it embedding, sorry, embedding dot pickle. Okay, pickle. Then sorry, embedded dot pickle should be, yeah, embedded dot pickle. Okay, now yeah, almost done. We have done our configuration file. Now from this configuration we will read this path. Okay, then we'll be creating this you can say folders and file. Okay, so if I go to my this generate folder. Okay, now we'll be importing some of the necessary packages. Okay, so first of all, what we need to do, because I have already told you, here we will be creating some of the artifacts folder, and in that artifacts folder we'll be saving all the, you can say, pickle file, whatever we are generating. Okay, so that's why like we have created this all utility, you can say, function here. Okay, so that like we can read the YAML file and we can create the directory here. Okay, so that's why we have like created this package, local package here, so that like we can navigate through this package right now. Okay, so how, like you can see from src see, now it is suggesting src, because src we have already created here. Okay, so now it is suggesting the src. Okay, so that's why we have created this package. Okay, src, then in the src there is also if I just click here, so you can see in the src there is also a folder called utils. Okay, so we'll be calling the utils, and in the utils itself there is a another file called all utils. Okay, so dot all utils will be importing from the all utils we'll be importing this read YAML and this create directory. Okay, so if you know the modular coding, I think you know what I'm trying to do. Okay, so import this read uh, underscore YAML, and also this create, I think, directory, or what is that, just let me check. Yes, create directory. I'll just copy that and I will paste it over there. Okay, so yes, I have imported this two function. Now I will import another package which is arg parser. Okay, import argument parser. Okay, so we'll be using that for passing the arguments. Arguments means we'll be passing the path of our configuration and the parameters file. Okay, so now we'll be also importing this OS module. Then I will also import this, you can say, logging here, because I will be logging each and everything. Then I will be also import this pickle, because we will be converting those you can say images to the pickle. Okay, so that's why. So first of all, let me write the logging you can say string. Okay, because logging string wise, see here we have also logged some of the, you can say, some of the you can say messages here. Okay, so how it is going to create, okay, how it is going to like you can say decorate all this log file. Okay, so we have to just define it here. Okay, because it is connected with that. Okay, so it will automatically take from this those information and it will be creating there. Okay, so what I'm trying to say, just let me define. I will just write you can say logging logging underscore str. Okay, because we are writing the logging string. Okay, here str, then logging string wise, like we will give this you can say bracket, then we'll be mentioning the percent here. Okay, then after giving the percent we'll be giving the first bracket, and we'll be telling our ASCII time. Okay, because it will be generating the time. Okay, so what time you are running the code and what time it is generating the log. Okay, it will just define the time also. Okay, so that's why like we're defining the ASCII time here. Okay, so you can do that, and after creating this ASCII time, we are also mention one percentage here, then our level name here, issue. Okay, so suppose you have got an error. Okay, so what is the error? So we will see in this, you can say, location. Okay, so with our with your time, you can say. Okay, so I will show you. Okay, so whenever I will be running, then I will be also created another, you can say, a module. Okay, so mo module. Okay, module means like whatever folder you are running, so it will just log that folder. Okay, then I'll be also just, you can say, saving the message. Want to save the message here. So yeah, this is the message I want to save also. Okay, so then after that, like I will also define the log directory, log dir. Log directory means I want to just keep the log in our root folder. Okay, so that's why like here I'm not defining any path. I will just define, you can say, log. Then I'll just create, you can say, this logs folder here. For that I'm going to use this wes mkdir. Okay, then I'm going to define this log path, log dir. Okay, then I'm going to define the parameter exist is equal to true. Okay, exist okay, I guess exist underscore okay is equal to true. Okay, just equal to true. Then I'm going to just now, you can say, configure the logging. Okay, so for that, like logging dot, like you can say, logging dot basic config. And then I will be defining my file name. File name is like where you want to save your log and what would be the file name. Okay, so I'm going to save it in wes dot path dot join. Okay, in our you can see log directory. Okay, and our logging file name would be running underscore log dot log. Okay, so this is the name, and we have to also, you can say, define the label here. Label is equal to log logging dot info. Then also we have to define the format. Format equal to, like, we will be defining the logging string. Okay, so let me define. And I also am going to define the file mode. File mode is equal to append. Okay, because we'll be appending. Okay, every time, so that's why we have defined the append. Okay, so yes, we have configured our logging string. Okay, now what we'll do, we'll just create one function. Okay, so before that, first of all, okay, so first of all, let me define the function. Okay, so definition of the function, I'm going to define generate data, you can say pickle file. This is the name. Okay, so you can name it anything. And it will take, you can say, configuration path. Okay, because your whatever configuration you have configured here, okay, this config.yml, so it will take the path. Okay, then it will read those, you can say, directory. Okay, directory or the file name, and it will you can say go through that, and it will read that, and it will generate all the, you can say, necessary information what we are trying to do. Okay, so that's why config path. Then we'll be also giving out parameters path here. Okay, so params underscore path. Okay, because in the param itself we'll be writing some of the parameters here. Okay, so that's why we have written, and then we'll be passing the function as of now. Then let me define the bottom of our you can say function. So in the bottom I will write if underscore name is equal to main. Then I will just passing all the, you can say, necessary you can say folder or files. Okay, whatever necessary, Okay, so whatever this function is taking, I will be passing here by using this argument parser. Okay, you can directly pass that, but by using this argument parser, like you can change it anytime. Okay, so suppose you are changing this configuration location, okay, from here to here. Okay, so at the time you can also like you can say give that, okay, in the runtime itself. Okay, so that's why we are doing that. Okay, so for that, like I will write args. Okay, args is equal to I will be write arg parser dot argument parser, arg parse dot argument parser. Okay, then I will just write arg, then add argument. Okay, so in this argument section we'll be just sending our configurations, so underscore config, then so add arguments wise, like we'll pass this hyphen config. Okay, so you can directly use that, or otherwise like if you want to set a short name, so you can also do that by using this hyphen c. Okay, so instead of config, you can also use hyphen c. Okay, and you can set default argument wise we'll be sending default our default is equal to wherever our config path is presented. Okay, so if you see in the config folder, there is a config.yml. Okay, so that's why we'll be mentioning config, then into that there is a file called config.yaml. Okay, yaml. So yes, I have passed that. Okay, then so simultaneously I will also, you can say, pass these parameters. Okay, here. Okay, so I will just copy that line of code and I will just change it, config to params. Then instead of c, I will write p. Then I will be where is my params. So this is in our root directory, so I don't need to give the path. Okay, so I can get rid of this path and I will just rename it to params. Okay, params.yml. Okay, so yes, I have given, okay, this parameters path, and now what I need to do then, and just you can say I will create a variable. Okay, so called first args. Then you can say, yeah, this is the function I will be run. Okay, but here I will be giving this you can say args instead of this parser. Okay, so it will automatically parse the argument. Okay, then I will write an try except block here. Okay, so try you can say this first of all it will be generating a logging. Okay, logging info. So in this logging info I will be writing stage 1 started. Okay, so so by saying that you will get to know, yes, your stage 1 is started. Okay, like in the stage 1, what we're trying to do, we are generating the you can say image pixel file. Okay, that is where like we are reading the file location. Okay, the pixel location from the folder itself, and we're saving the location and the file name, okay, in a pixel file. Okay, so in the first location we are doing that, I have already explained. Okay, then I will call my function here. Okay, so generate pickle file. Okay, so this is the function I have you can say written. So in that function I will be passing, okay, this config path. So whatever like we have given. Okay, so the argument, okay, so will be like config path, and here we have passed the argument. Okay, so we will be just write this first argument dot config. Okay, because first of all we are just you can say passing the config, so that's why we have defined the config. And the second argument wise this params path. Okay, so you already seen. So in that I will be just write parse this yeah parsed underscore args dot this params, okay, because I'm giving my parameter location, okay, there. Now it has been done. So let me again close the log here, okay. So logging info, now I'm closing the logging info, so that's why like I can say stage you can say 01 completed, okay, completed, okay, yeah. So it has been completed, okay. uh, okay, let me define it, okay. Yeah, it has been completed. Now in the exception, you can say exception itself, I will be writing except exception as e is suggesting already, okay. And here I will be just raising the, you can say exception here, okay. So you can say logging exception e, okay. So here we have defined the exception as e, and we're raising the you can say exception, okay, in our log, and we'll be also raise in our terminal. So that's why we'll be write this raise uh, sorry, raise e, okay. So it will be raising in our terminal itself, okay, so that we can get to know. Sorry. Mm. So most of the thing we have written, okay. Now we'll be creating our main function here, okay. So whatever we have discussed till now, so first of all let me just read this you can see YAML file, okay. Just let me read those you can say directory, okay. We'll be reading all the directory here, and we'll be reading, you can say all the file, okay, and we'll be creating. So for that, like I'll be, you can say, first of all, like we'll be reading the config, okay. So that's why I'm going to name it config, and config read YAML, okay, because we have already you can say import this read YAML, okay. It will be reading this YAML file. So first of all, we'll pass our config path, okay. So from this config path then it will read, then I will just reading our params, okay, parameters. So parameter wise, like I will be define this, you can say read parameters, okay, read YAMLs, okay, and I'm going to pass this parameters path here, okay. So it will be reading this parameters path also, okay. And also my artifacts, okay, artifacts, okay, artifacts I can say I can mention it, because why I'm reading these artifacts, because see, this is the key, okay. In the artifacts there are some of the, you can say also key like dictionary, okay. So that's why first of all we are reading these artifacts, okay. Then we can name it, we can read it easily, okay. So whatever I'm doing, just see, first of all I will be just reading our config, okay. Config, and configs, inside the configs so if I go that, so it is reading the this config path, okay. That means this config file, okay. So if I go to this config, so you will see we are reading what config itself, we are reading this artifacts, okay. In the artifact itself there are some of the keys and values, okay. So we are also reading that. So that's why, like first of all we will be reading this, you can say keys, okay, config this artifacts, okay. And from this artifact itself we'll be retrieving some of the information like artifacts dir, okay. So artifacts artifacts underscore dir. So where is our artifacts underscore dir? Inside the artifacts, okay. So this is the artifacts, okay. This is the artifacts, and if I open up this folder, so this is the artifacts we have so we are in now, okay. So if I show you, yeah, we have read this you can say config path, okay. And we have also read this artifacts, these artifacts, and in the artifacts itself, okay. So there is a path called artifacts dir, okay. So we are reading this, you can say folder name, okay. So we'll be just copy that key, and we'll be just paste it over there, okay. Yeah, we have got this artifacts dir, and we'll be also reading this pickle format data dir, okay. So let me copy that, pickle format data, copy, let me paste it over there, and dir, data dir, it's fine. Then it is inside the artifacts, uh, pickle format data dir. Okay, so if you see, so this is the name, pickle format data dir. Inside this there is a folder called pickle format data. Okay, so we are reading that. Then we'll be also reading, you can say, this image pickle, image pickle dir. Okay, so image pickle, I can say this image pickle file name. So what is the file name we have set? So we'll reading, so image pickle file name. So this is the file, so this is the key. If we call this, if we call this this key, okay, so it will return this value, okay, like dictionary. Okay, so whatever we do, so here we'll be mentioning this image pickle file name. Okay, so we have got, you can say, all the necessary file path and file name. Okay, now we'll be just creating our raw local dir. Okay, so whatever we are going to save, so raw local, uh, raw local, sorry, it would be local dir path. Okay, so here we'll be like writing os dot path dot join, then our artifacts dir. So this is the artifacts dir. Artifacts dir means this is the artifacts directory, and artifacts dir, then we are joining this with this, you can say, pickle format data dir. Okay, so we are joining that with this pickle format data dir. Then we'll be creating that directory first of all, okay, in our local. So if we just call it create, create directory, and here we have to pass the list because we have already mentioned. And here, so let me write, we have also named it a directory. Okay, so if you open up that, so here it takes a directory, okay, as a list. So we have also passed it, and we'll be just giving this raw local dir path. Okay, so if we give that path, okay, so it will automatically create that path here. Okay, so let me run that code, I will show you. So for that I will run python in src stage, sorry, 01, I guess. Okay, okay, sorry, yeah, 01 generate.py. So if I run that, so you will see there, yeah, there is the error I got. Okay, so let me see that. So guys, this is the error I got. You can see key error, label name. Okay, because I have given the wrong name. Okay, so it should be E instead of A. Okay, so I will saving that, and if I run that it again, okay, so you will see it will not throw any error. Yeah, it has successfully ran. Okay, so okay, let me delete that one because I have changed the, you can say, log names here. Okay, logs. So if I open that, okay, so you will see all the logs it has been generated. Okay, see, this is the time, okay, it has generated. Then this is the information. Okay, so this is the information, that's why it is telling the label is information right now. And this is the folder name. Okay, so if I open that, so here we have mentioned, okay, so this is the ASCII time, then label name, this is the module. Okay, module name means this is the file name, whatever it is running. And this is the message. Okay, so this is the message, like whatever we have written here. Okay, so if you see here, here we have written stage 1 started. So you will see here it is also telling stage 1 started. Okay, then directory is created at this file. Okay, so if you click on that, so this is directory is created at this file. Okay, so all the logs it is generating. Okay, so that's how like you can keep tracking your log information so that you can easily debug the information. Okay, so that's why we're creating this log file. Instead, like, you can also print it in your terminal, but it is not a good you can say practice for like to print the logging information in your terminal. Okay, so every time you need to save the log, you can say, in your project directory itself. Okay, so that like you can utilize it later for debugging purpose. Okay, so yeah, that's why. So yes guys, it is running successfully. Okay, so if I go to my you can say root directory right now, so you will see there would be a folder that will be generated called artifacts. Okay, in the artifacts itself there will be also a folder called pickle format data. Okay, so we have created that. Okay, so whatever we have written here, this configured file, okay, so the artifacts, in the artifacts file, pickle format data we have like created here. Okay, by using you can say this line of code. Okay, we have created, and inside this you can say pickle format data, we'll be saving our you can say pickle file, like whatever image we are going to convert it to pickle file format. Okay, so we are going to save it over there. Okay, so now what I'm going to do, we have, you can say, right now I've created the file. Okay, I guess I have created the folder. Now I need to just read the file name. Okay, so what file name I'm going to use for saving the file. Okay, so this is the file name I'm going to read. So for that I will write another line of code. So pickle file, pickle underscore file. Okay, so what is that pickle underscore file? Because I'm going to save it, so that's why like I will write west dot path dot join. Then you can say this this local data path. Okay, in this local data path, that means this local data path, that means artifacts dot this pickle format data. Inside that I'm going to you can say name it like I'm going to save one pickle file, which would be like name is you can say image pickle file name. Okay, image pickle file name. So we have already read this file, image pickle file name here. Okay, so we'll be just passing this you can say name here. Okay, so image pickle file name. So yes, we have our pickle file. Okay, now what we'll do, we'll just now read our data. Okay, we'll be reading our data. So for that I will open up my params. Okay, so in this params I'll be create another key which is base, and in this base like I will just write data underscore path. Okay, so where is your data? You can define the path, data underscore path. And for now our data is in the data folder. Okay, so if I click on that, so here is my data. So I will just data. Okay, I will just give data. Suppose if you suppose if you have your data inside this, you can say srcs. Okay, at the time you can mention the path here like that, src slash data. Okay, so you can also give that, but as of now is data is in our you can say root directories. That's why we're giving this information as data. Okay, so now we'll be reading this params file. So we are already in this param files. Okay, so in the params file, from the param file itself. Okay, now we'll be reading the data path. Okay, so like that I will just define data underscore path, and here I'm going to like call my params, and yeah, this is the data path. It is automatically suggesting because I'm using this tab 9. Okay, so it will be suggesting you. Okay, so if you install this extension in the VS Code. Okay, so if I go that, so in the params, okay, there is a you can say key dot base. Okay, so I'm reading this base here. So you can see okay, so let me read this base first of all. Here first of all we'll be reading this base. Yeah, now if I open that, so here first of all we are reading this base key. Then in the base key itself there is a also folder I mean there is also key called data underscore path. Okay, so if you I mean read that, so it will give you this data. Okay, data folder location. Okay, so yes, we are reading that. Now what we will do, we'll be just you can say reading those you can see information, reading those data. Okay, uh, so that's why like what we will do, so I will be creating one folder, one you can say variable actors. So I will just you can say reading all the you can say folder west dot you can say list dirs. Okay, then I will just giving my data path, and if I print that, so I will show you what I'm trying to do. Print this actors. Okay, so if I print this actors, okay, so if I run this file again, So you will see it is reading all the, you can say, celebrity folder name. Okay, so you can see first of all it is reading, you can say, this Amir Khan. Okay, so if I open that, so see it is reading Amir Khan, then Abhi Doyle, okay, then Abhishek Bachchan. Okay, so it is reading all the, you can say, folder name, okay, from your data itself. Okay, so yes, here we are doing like that. Okay, now what we will do, will be just, you can say, yeah, we'll be just, you can say, gone through this folder, and in the each folder we'll be taking all the file, okay, all the file location, and we'll be saving in a list. Okay, then we'll be converting into a pickle format. Okay, so what I'm trying to do, let's see. So I'll be like create an empty list here. So I'm going to name it like, you can say, file names. Okay, file names into the it is a empty list. Then I'm going to run, you can say, two for loops here. One, it will go through this folder, and second for loop will be like gone through this, you can say, file name. Okay, so I am going to do that. So for you can say actor in, you can say, actors, and what I'm going to do, then it is reading all the, you can say, actor folder. Okay, and from the actor folder itself I'm going to read this file. Okay, so for that, like, I'll be just performing another loop. Okay, so for file in os dot listdir. Okay, uh, listdir, and in this listdir I will be passing my, you can say, path. Okay, or you can say this folder path. Okay, so for that, like, I'm going to give the data path first of all. No, not data path. I'm going to just sending the paths. That's why I'm going to use this west dot path dot join. Okay, then I'll be passing my, you can say, data path. Data path means like you are getting see data path means like you are getting okay, your data. Okay, this is the data. Okay, this is the data path, and in the data, okay, so there is a also, you can say, actor. Okay, so I'm passing the actor folder here. Okay, so here it will give you, so if I print this, you can say, file, if I print this file, so you will see, it is giving, you can say, all the, okay, all the file. Okay, all the file here is presented. Okay, so it is giving all the file. Okay, so that's how we're like reaching this, you can say, reaching to this file name. Okay, and after reaching this file name, I'm going to, like, you can say, save it, you can say, save it in a, in this list. Okay, empty list. So for that, like, I'm going to write another lines of code. So I will be writing this, you can say, file name, then file name, then dot append. Then I will be just you can say, I'll be not saving this, you can say, just individual, you can say, file name. Okay, I'll be saving the entire path. Okay, so for that, like, I will just define the path here. Okay, so west dot path dot join. Then I will be just define the path. First of all, I will give the data path, then I will be giving this actor. Okay, this folder location, then I will be giving the file name. Okay, so now if I, you can say, run that. Okay, if I run that, if I print this, you can say, file name, this list. Okay, and if I show you the lane, print lane of this file name. Okay, so here you will see, here you will get the idea. See, it is reading all the file location. See, first of all, data, then, okay, so if I go to the top, so I think I can explain it better. Let me I mean explain it here itself. Okay, first of all, it is going to the data. If I go to the data, so then it is going the Zarin Khan. So where is the Zarin Khan? Well, this is the Zarin Khan, and from the Zarin Khan itself, it is taking you can say Zerinkan 94. Okay, so it is also taking all the Zerinkan photo. Okay, so see, it is reading all the data location, okay, from your data path itself. Okay, so that's how we're, you can say, getting the data path, okay, by using these lines of code. Okay, and if you see the total data, okay, are presented is almost more than 8,000. Okay, like 8,664. Okay, so I think initially we have assumed that there are, you can say, 8,000 data set, but now you can see more than 8,000 data we have in your data folder. Okay, now we have read this file location. Now we'll save in a pickle format. Okay, so for that, what I'm going to do, first of all, I'm going to generate the log. Okay, because we have read this file. Then first of all, I'm going to just you can say log, generate the log info. Then I will be writing, you can say, I'm going to create a string. Then I will be writing total, you can say, actors are um, if I total actors are, like, you can say, if you perform the len on these actors, um, actors, I'm talking about like these actors. Okay, so you will see there are 100 actors. Okay, and also I'm going to log this, you can say, total actress image wise, like here we have file name. Okay, file names. Okay, so yes, we have generated that, and now what I'm going to do, I'm going to just dump it to the pickle format. Okay, so for that, like, I will be calling the pickle.dump. Then I'm giving my, you can say, list. Okay, list here, and I'm going to just open a folder, open. Then I'm going to just give my pickle file. So this pickle file we have already, you can say, defined over there. Okay, I'm going to give the pickle file, and I have to define what should be the, you can say, format. Okay, so this should be the right binary format. Okay, we have defined. So if I run that, okay, now let me run that code. Now you'll see there would be a file. Okay, there would be a generated file called, you can say, this if I show this config file, so image pickle file.pickle. Okay, so if I run that, see, if I run that, so see, if you go to your artifacts. Okay, if you let me go, if you go to your artifacts, and if you go this pickle format data, so you will see this image pickle file, pickle has been generated. Okay, so in this pickle file, here we have all this, you can say, file location, okay, are presented. So yes, this was our first step we have done. Okay, so yes, like that we can, you can say, read those folder location, file location, and you can save the you can say data location in the pickle format. Okay, so later on we can utilize that in our, you can say, actual model. Okay, so now our first step has done. Okay, so if I show you the log here, so see, all the log has been generated, and see, this is the, you can say, stage one completed. Okay, stage one. Okay, so there was a previous log. Okay, and if you see from here itself, stage one started, and you can see, yeah, total actors are 100, and total image are 8,000. Okay, 8,664, and this stage one has completed. Okay, like that you can track the log also. Okay, so yes, I have done. Now we'll be creating our second stage. Okay, so which is you can say, we'll be creating. So for that, like, I'm going to create touch, you can say, 02. This is our second stage in the src. Then 02, 02, then will be our second step would be the feature extractor. Okay, so we'll be extracting the feature. Now we have the data location. Okay, now we'll be reading the data, then we'll be extracting the feature. Okay, so as we have already explained, we'll be passing the data in my model. Okay, in my VGG face model, and it will be extracting the feature from these images. Okay, then it will contain, you can say, it will be generating a feature list for us. Okay, then each feature, it will be containing 2048, you can say, information, okay, in each array, okay, and there would be 8,000 and whatever was my, you can say, yeah, there would be 8,664, you can say, arrays, okay, in our feature, you can say, list, okay, and each feature will contain 2048 information, okay. So yeah, we are going to do that. So here, what I have to do, I have to just okay, let me delete that I have created. So I will just create it, feature, feature extractor, okay, dot py. So yes, I have created this feature extractor. Then I will be writing my, you can say, second stage code here, okay. So guys, as you have already seen, we have done our first stage, okay, so which is like generate image pixel. Now we are going to start our second stage, which is feature extractor, okay. Now what we'll do, we'll just copy the rest of the code from here, okay, because we are not going to write this thing again. Then we'll modify this code, okay, as per our requirement, okay. So I will just get rid of some of the part. So let me get rid of that. So for that I will just remove, you can say, uh, this part, okay. This is not necessary for me. Otherwise, like, I can keep this function and I can change that. So let me just do that. I will just get rid of okay, that. Then I will just, you can say, name it feature extractor, feature underscore extractor, yeah, feature extractor. Then I will just copy that function name, then I will just paste it over there, okay. Then I will just keep here stage 2 started and stage 2 completed, okay. Yeah, rest of the thing is fine, I guess. Now what I'm going to do, I'm going to just define the import, okay. So these two files is necessary, so I'm going to keep that. So everything I think is necessary, but I have to just import some of the you can say important library for that. So I'm going to use this from TensorFlow, um, TensorFlow dot keras. I'm going to import pre-processing import image, okay. So this pre-processing we need because we are going to pre-process our image, okay. So at the time of this function is important, okay. Then I'm also going to import, you can say, this keras vgz face, okay. Keras then underscore vgz face, okay. Then dot utils, I'm going to import pre-process input, pre-process pre-process input, I guess, pre-process underscore input, yes. And also I'm going to use this keras vgz face, um, dot vgz face import vgz face, okay. So we're going to import that. Then we'll also need the numpy, import numpy, as np. Then also I need the tqdm, okay. So okay, import numpy as np, oops, np. Then import this tqdm, import tqdm, okay. So why we're importing this tqdm, So from import, okay, because from whenever you want to see the progress bar, okay, so at the time you can use this tqdm, okay, by seeing for seeing this progress bar. So now we'll be writing our feature extractor function, okay. So first of all, I need to just read this file, imsql file, okay, from this directory. So for that, like, we have already the file location here, okay, so just we will just integrate the path. So for that, like, I will just write imsql uh, imsql file, this west.path.join. I can use you can say artifacts dir, artifacts dir. Then in the artifacts dir there is a folder called pickle format data dir. Then this image pickle file name, okay. Yeah, so I got the path. Now I have to read this file, so I will just write file name underscore you can say pickle dot, you can say load. Now I will just pass this. uh, Before that, I will just open, then I will pass that, okay. Then I have to also define you can say the format, okay. So I'm going to read it with the rb, that means read binary format, okay. So after reading that file, what I need to do, uh, so I have this file names, okay, so I will use this file names, okay. So whenever, like, we're going to read those you can say picture, okay, from this pickle itself, okay. Now what we need to do, we have to just configure our model, okay. For that, first of all, like, I need to open up this params.yaml, okay. And in the params.yaml, I will just define some of the parameters. So first of all, I'll be defining the base model, okay, base underscore model. So uh, for the base model, I'm going to use, you can say, this resnet 50, resnet 50, okay. Resnet 50 are going to use, and include top, include underscore top, okay. Include underscore top wise, like, sorry, include underscore top wise, we can mention false, okay. Yeah, because uh, we are just including, you can say, including this if I show you the image, okay, let me show that. uh, so yeah, this is our VGC face, you can say, algorithm, okay. And in this you can say architecture here, we have two parts, okay. So one is our CNN, okay, convolutional neural network part, and one is our, you can say, this artificial neural network part, okay. So we are just you can say include underscore include top underscore false, means we are just get rid of this part, okay, because we need that part, okay. By using that part, we'll extract the feature, okay. So that's why, like, we're, you can say include underscore top is equal to false, we are just writing here, okay. Then okay, then we'll also write this pooling, okay, whatever pooling we're going to use. So in that one, I'm going to use the average pooling, okay. So avg I can write. Now I'm going to save that file, then I'm going then I will go this feature extractor.py. Then I'm going to read all the parameters here, okay. So I have already read the parameters, so just I will just import that, okay. So model, you can say model underscore name is equal to params model names, okay. So not model names like that, I think. First of all, I need to see, okay, first of all, there is a base, I need to read base, and after base there is a, you can say base model, okay. So I'm going to read that, yeah, base model, yeah, that is fine. Then I've read this model name, then include underscore top params. So I'll just copy that code, paste it over there, base, and I will just, you can say, include underscore top. I will just yeah, I will just paste it over there. And another is like pooling. Okay, so I will also read this pooling. Okay, pooling, uh, base underscore pooling. Yeah, so yeah, I have read that. Okay, so these three, you can say whatever we have, you can say whatever we have mentioned here, we have just you can say read here. And now we'll be designing our model here. Okay, so I will just define model, and I will call the VGG, you can say face, VGG face. Then the base model wise, I'm going to pass, you can say, this model name, model, I'm just copy that. Okay, sorry, copy, paste. Okay, now this include top. Okay, include tops, equal to tops. And you can say pooling is fine, poolings. And also you need to mention, you can say, this input shape. Okay, because this model will take 24 to 224 into 224. Okay, so we have to define the input shape also. Input underscore shape is equal to, I have to define 224 times 224 and 3. Okay, 3 means the channel of the images. Okay, that means this is the RGB images we are using, so that's why we are mentioning that. Okay, so yes, we have configured our model also. Okay, so now let's define. So we have configured our model, and now what we need to do, now we'll be you can say creating, you can say, some of the directory here in the artifacts folder. Because whenever now what I'm going to do, okay, so let me explain it briefly. So here I have already discussed, see, this is the, you can say, images we are loading. Okay, we are reading and we are converting, you can say, into 224 into 224. Okay, so I will convert that. Okay, once I will read this function. Okay, I will make another function here. Okay, which will pre-process the images, it will resize the images. Okay, in the desired, you can say, size. Then I will just passing to the model. Okay, this model will pass, this model will give me an to the array. Okay, this, you can say, embedding. Okay, that means the list of the vectors. Okay, then after getting the vectors, I will be saving it to the, you can say, pickle format. Okay, I will saving it to a pickle format. So pickle format I will be saving it. Okay, so that I need this, so that I can use this, you can say, vectors. Okay, once I get this prediction images. Okay, then I can compare with the, you can say, old one. Okay, I will just measure the cosine similarity between them, and I will just and I will just, you can say, retrieve those images. Okay, which is similar to this, you can say, prediction images. Okay, so this is the our entire, you can say, architecture. So now here we'll be converting this array to the pickle format. So for that, like, I need some of the folder. I will just, you can say, create, and I will save it. So here, if I open up this configuration file, so here I have already written this extracted feature folder. So in the artifacts folder, we'll be created this extracted feature folder, and in the extracted feature folder, we'll be creating this embedding dot pickle. Okay, okay, pickle, sorry, embedding the pickle will be creating. So let me do that. So for that, like, I will you can say, first of all, you can say, let me define a variable. So feature, uh, feature underscore extracted dir. Okay, then I will be calling the artifacts. Then in the artifacts itself, there is a you can say, key called feature extraction dir. I'll just copy that and I will paste it over there. And yes, I've done. Then extracted feature name, I have to also you can say retrieve from there. Extracted underscore features underscore name. So artifacts extracted feature name, I guess. Okay, it is suggesting extracted feature name. So let me check out. Yeah, extracted feature name. I have to copy and I have to paste it over there. And after that, like, I will join this path. Okay, so let me join that. So feature extraction path. Okay, feature extraction path. West dot path dot join feature extraction dir. Then I'll be calling this. Okay, not feature extraction dir. First of all, I need to pass this artifacts dir, because I'm going to create in the artifacts itself. Then after that, like, I will be passing this feature extraction dir, because this is the main folder we're going to create. And now let's call our create directory. Then I will just you can say pass the list of the dirs. Okay, so dirs equal to list of dirs I will pass. So I will pass this, you can say, feature extraction path. Okay, I have passed. Then it will create you can say this artifacts. Okay, in the artifacts itself it will create a feature extraction path. Okay, and in that path you can say I'm going to save that one. Okay, so if I run that, so I will show you. So if I save it and if I run that file, so Python into the src, I will run this stage 2. Okay, stage 2. Okay, stage 2. So see, if I run that, it's taking time because it is running the TensorFlow in the backend. Okay, so that's why, and it will keep some of the, you can say, warning. Okay, so you don't have to worry if you have CUDA set up in your system, so you will not get this kinds of error, this kinds of warning. But in my system I have no, you can say, GPU or no CUDA. Okay, so that's why I'm getting this you can say yeah, warning. So I will wait. Okay, I'm getting this error because I have mentioned the tops here, so it would be top. So I will run it again. Yeah, so now if you go to your folder, okay, in the artifacts itself, so here you will see there would be another folder called extracted feature. Okay, so if you click on that, there would be nothing, but this is what I wanted to create. Okay, so now in this extracted feature I will be saving my you can say embedding.pkl file. Okay, so whatever feature we are extracting and we are converting to the you can say numpy array, will be saving in a pkl format in this location. Okay, so now what I'm going to do, we have already generated, you can say, this folder. Now I'm going to just, you can say, join this folder location to my file, you can say, file name. Okay, so for that, like, you can say this I'll write this feature name, then west dot path. Okay, west dot path dot join. Sometimes it gives. Yeah, with the path dot join, then I will just give this feature extraction path. Then I will also give this extracted feature name. Okay, because this is the name my, you can say. Okay, so if I show you extracted feature name, this is nothing but it's a embedding.pkl. Okay, I think you're getting that now. Yes, I got the feature name also. Okay, now what I need to do, I will just, you can say, I will just you can say iterate through this, you can say, this pickle file. Okay, I will just already I have load this pickle file. I will now, I can, you can say, read those, you can see, image location, and I will just read it, and I will just pass it to my extractor function. Okay, so extractor function, what it will do, it will just read the images and it will convert it to my, you can say, desired you can say desired output. Okay, like we'll be just resize the images. Okay, then we'll be expand the dimension, then we'll be passing to the model, and the model will be like extracted the feature, and it will be like flatten the, you can say, feature, and it will be like, you can say, giving the output. Okay, so like that will be also performing. So for that, like, I'm going to create, you can say, a list, empty list here, features, because here we'll be saving all the feature. Okay, now I'm going to perform a for loop for file in tqdm. Okay, tqdm, why I'm using this tqdm, because I want to see the progress bar. Otherwise you can also ignore that. Okay, because I'm using this tqdm because you can see the progress bar, what is going on. Okay, how many time it will take, so you can see that. Okay, so that's why I'm using. So here I'm passing this file names. Okay, because file names, what is file names here, because this pickle file what we have loaded. Okay, so we are just passing that, and from the pickle file itself, I will just feature feature dot append. Okay, this feature dot append, then I will call my extractor function. This function I haven't created yet, but I will create it. Okay, once I will complete that. uh, so extractor function, I will be passing my file location and my model also. Okay, whatever model I have configured right now, this model. Okay, and it will automatically, like, you can say, extracting the feature. Okay, and it will be appending in this feature, you can say, list here. Okay, so let me create this you can say extractor, you can say, function. So I will just copy this function name and I will define it here. So define extractor, and what this extractor function will take, it will take the image path times the path, because we are already passing the path, and it will take the model. Okay, model, and yeah, after getting that, what I'm going to do, first of all, I'm going to load the images. Okay, so for that, like, I will use this image. This is the image. Okay, pre-processing from the TensorFlow, I'm using that image dot, you can say, there is a function called load image, I guess. Okay, load image, and in the load image itself, you will pass, you can say, this image path. Okay, whatever path you are getting, you will just pass it over there. Okay, then you will just define the target size, target underscore size, I guess. Target size wise, you will define 224 times 224, because we have already seen whatever image we have, okay, in our data folder, it is the pixel wise, it is 64 into 64. Okay, but we have already seen our VCC phase, it takes 224 into 224. Okay, so that's why we're converting, we're resizing the images, I mean 64 to 224. Okay, so I think you're getting the idea. Okay, and now we have the images. Okay, now we will be just converting these images to the numpy array. Okay, so for that, like, I will just write array image array, then I will just write image dot, you can say, image to array. Okay, image to array, there is a function, it will automatically, you can say, convert it to array. Then I got the array. Now I will just expand the, you can say, now I will expand the dimension. Okay, so why I'm expanding the dimension, because I think you will already know, okay, whatever model you are using, okay, it takes you can say dimension wise, like you can say, it will all, here we have seen, here we have three, you can say, um, it will also take the batch dimension also. Okay, so that's why we are making we are expanding the dimension. Okay, here, so see, here we will be mentioning expand date image. So from the numpy itself, np dot expand image, expand dimension, I guess. Then I will be passing my image array. Then I will also pass this axis. Okay, in the axis 0, I'm going to you can say expanding my dimension here. Okay, because see, whatever I am written here, I'm going to explain. See, because I have, as of now, if I write it over there, so I have 2 to 4, 2 to 4, 2 to 4, sorry, 2 to 4 times 3. Okay, this is the dimension I have. But if you have already learned the CNN or this you can say image processing, okay, so you will see every model takes, you can say, another extra dimension, which is your batch dimension. Okay, so whatever batch you are giving, okay, batch of the images, okay, so it will also take. So suppose here you are taking 8 batch, okay, 8 batch, so your dimension would be 8, 2 to 4, 2 to 4 and 3. Okay, so this is the dimension at that time. Okay, so here we are just defining our dimension. Okay, so where I guess yeah, here we are just defining the dimension in the 0 axis, because we are telling it would be our we can say batch dimension. Okay, we are increasing. I think you got the idea. Now we have the expanded images. Okay, now we'll be, you can say we'll be giving the pre-processing input. Okay, so it will pre-process the image. So for that, like, we'll be write pre-process image, and I will be pass it pre-process pre-process input, and I will pass the expanded image. Okay, expanded image, I'll pass it. Then I will be getting the pre-processing image. Okay, so it will do the all stuff, okay, whatever we have done right now. Then I want to see my result, so I will be creating a result. Then from the result itself, I will be passing this data to my model, model dot predict uh, predict. Then I will be just passing this pre-processing input. Okay, it will give me the, you can say, this features, this you can say 2048 features. Okay, then I will be just flatten this feature, you can say flatten, because I want this would be a flatten. Okay, then I will be just, you can say, return the result. Okay, yes, so this is the function we have written. Why this is showing like that? Okay, now it's okay. So yes, we have created, you can say, all the necessary things. Okay, now we can, you can say, give this you can say data to my you can say feature extractor, you can say function. Now it will do my job. Okay, so like that, I just want to, you can say, log the information. And after getting you can say I will be saving this you can say features, okay, to a pickle format. So I will be also writing that. So pickle underscore pickle dot dump, pickle dot dump. Okay, so this feature I'm passing here. Okay, so whatever feature I'm just appending, okay, I'm just passing it. Then I will open the feature name. Feature name means, like, we have you can say already created this you can say this location. Okay, then in the artifacts, this expanded feature, we'll be opening that. And I'll be just, you can say, mention it right binary format. Okay, it will be writing. So yes, I think almost we have done our projects. Okay, so let's run that. Okay, so it will take some time, because it will take every images, okay, and it will convert it to you can say numpy array. Okay, after converting to numpy array, it will be like saving it to the pickle format. Okay, so that's why it might take some time. And because there are almost more than 8,000 images, okay, we have, so it will take some time. So we'll be waiting, okay, until it finished. Okay, so I'm going to run this you can say you can save this code. Okay, let's see what happened. So I'm going to run. So let's see. Okay, so it is telling object attribute not to predict. Okay, so let me check where we have defined the predicts. So guys, this is the error I'm getting because in the parameters.yaml file I had mentioned this ResNet 500, so that's why actually so I haven't noticed that. But here I have to write this ResNet 50. Okay, and now if I this you can say run this feature extractor. Okay, so you will see this training I mean this extractor will be working. Okay, so let's see it is work or not. So guys, you can see it has started. Okay, and we'll see the progress bar once yeah, so now see the progress bars I mean it is starting. And now I think you're getting the idea why we have used this tqdm. Okay, because by using this tqdm you can see the progress bar. Okay, so see here it is showing that many of file you have. Okay, and this is the file it is covering. Okay, so yeah, you can also see the percentage of your progress. Okay, and you can see all the loading icon. Okay, so we'll wait. Okay, until it finish, then we'll be come back. So guys, we have come back. So as you can see, our feature extraction has been done, and you can see here if I open up this extracted features folder. Okay, so you will see there is a file called embedding.pkl. It has been generated. Okay, so if I show you manually, so if I go to this artifacts folder, and if I click on this extracted feature. Okay, so you will see there is this embedding.pkl has been generated. Okay, now we'll be using that file. Okay, for measuring the cosine similarity. Okay, whenever user will give any kinds of you can see input image. Okay, so we'll be converting also in a numpy array, and we'll be like measuring the cosine similarity with respect to all the images we have in our database. Like database means like we have like generated this embedding.pkl. Okay, so we'll be you can say measuring the cosine similarity. Okay, so yeah, I have done this you can say our stage 2. Okay, so our important 2 stage has been complete. Now we'll be creating the entire app. Okay, so that the user can like integrate I mean interact with the application. Okay, so for that I'm going to create another you can say file. Okay, in the root directory. So I'm going to name that file so touch. So if I write it touch, um, I will name it file app.py. Okay, app.py, and if I hit enter, so we'll see there would be a file called app.py. Okay, so this is the file we have like generated right now. uh, so here first of all we'll be importing our necessary you can say libraries. Okay, so that we can utilize in this folder. So I'm going to you can say import. Okay, so I will use here this from Keras uh, vgz face and dot utils. I'm going to import pre-processing input. Okay, pre-process input, and also I'm going to import from Keras underscore vgz face, vgz face I guess, yeah. Then vgz face import vgz face. Okay, then also I'm going to import from src dot utils dot all utils, import read yaml. Also we'll be importing our create directory, create underscore directory. Also we'll be import pkl Then after pkl, from the sklearn itself we'll be uploading the cosine similarity. So from sklearn, sklearn matrix, uh, matrix dot I guess pairwise import, then cosine similarity, cosine underscore similarity, yes, cosine similarity. Also will be importing our streamlet, as st. Okay, st. Then also will be from pil import image, then also will be using this OS operating system module. Then will be also import our cb2, then also this mtcnn, import mtcnn. Okay, it should be mtcnn, yeah. Then I'm also importing the numpy as np. Yeah, almost we have imported all the necessary, you can say, packages, whatever we are going to utilize here. And now first of all let me read those YAML file. Okay, so for that, like, we have already written the code, so I will just copy and paste it over there. Okay, just this is the line. I will just copy that, and if I go to my app file, and I will just paste it over there. Okay, config it should be, and here I will be mentioning our, you can say, config path. So I will just copy from here, and then our, you can say, this params path also. Okay, sorry, yeah, I have done. Now I'll be reading, you can say, this artifacts dir. Okay, so from here itself I'll be reading artifacts dir. These two lines of code I will be utilizing. Yeah, and first of all we'll be creating another, you can say, folder here in this artifacts directory, because user will be uploading, okay, lots of images. So we just want will be saving this, you can say, user input images in a folder called upload. Okay, so that's why, like, this data would be saved. Okay, then from that we'll be reading the data, okay, and we'll be converting to the embedding. Okay, so for that, like, you can say, I'm going to you can say open, just close that. I'm going to open my config file. Okay, and in that config file I will be mentioning, you can say, one directory name, so which would be upload image dir. Okay, so upload image dir, and the folder name would be upload. Okay, so yes, I have saved it. Now if I go to my app.py, and now I'll be comment out, and I'm going to create the upload, you can say, dir here. So upload underscore, you can say, image underscore dir. So it is in the artifacts folder. Upload image dir, I guess. Okay, yeah, upload image dir, and we'll be like also define the upload path here. Upload path os.path dot join, and I will be just writing artifacts and upload it. You can see image dir. Okay, so yeah, actually I think I've yeah, done that. And now we'll be like mention our pkl format data dir. Okay, so let me comment it out. Pkl format data dir, because I think you remember here we have generated this pkl format data dir. Okay, see, I'm going to tell you the flow of this projects again. Okay, we have created this two stage because every time we don't want to run this two stage. Okay, we will run this two stage. One, we are changing the images. Okay, suppose you have more images, okay, of the Bollywood celebrities. Okay, suppose you want to integrate, so at that time you will keep these images into your data directory and you will run this two stages at that time. Okay, I will show you in a one you can say click how you can do that, but I'm just telling you. Okay, and in this app.py you will write the entire code. Okay, these are related to the you can say web app. Okay, so whatever we have you can say written, okay, as of now we'll be writing the same things here also. Okay, so let me do that also. So first of all, I'll be reading this, you can say, pickle format data from the directory itself. Okay, so let me do that. So here I think I have this created this you can say yeah, so this is the path, I think. Okay, so I'll be copy and paste it over there. The same things last time, just copy pasting. I think you're getting the idea. And also like um, also like I need the, you can say, file name also. Okay, so for that, like I will be, you can say, reading that. So this line I need paste. I need also this line. Okay, so yeah, I have done that. Now what I'm going to do, now I'm going to define my feature path. Feature path means like we have extracted the features. Okay, so we'll be going through this path also. Feature path. So feature path here, I think I have mentioned all the thing. Okay, so I'll be just copy pasting feature pathwise. Like if I go that, so this line of code I will be copy and I will paste it. Okay, sorry, yeah. Then I will again go to this file and then I'll be copy these two line of code. Again I will go there and paste it. I don't need that line. I will get rid of that. So guys, yes, now we have all the file location. Okay, whatever we have generated till now. Now we'll be reading our parameters here also. Okay, so for that, like I will be open the parameter. So here I think we have already you can say, yeah, read some of the parameter. I'll be copy and paste it over there. So guys, actually we have all the parameters and the path. Okay, so now we're going to, you can say, start our Streamlit actually web app. Okay, so for that, like I will be writing some of the code. So this is for Streamlit. Okay, so for starting this Streamlit, so first of all you will write st dot, you can say, title. Okay, so if you just write it, and let's say I'm going to give this project name. So to whom does your face match? Okay, so this is the title I have given. Okay, now for running this, you can see Streamlit. Okay, so in the terminal itself you have to write Streamlit uh, Streamlit run, you can say app.py. Okay, so if you run that, so it will be starting. Okay, so it will you can say open a live server. Okay, so it is showing an error because we have given the cosine similarity, but it will be cosine similarity. Okay, so if I again run it, so guys, you can see this title has been okay pop up here. Okay, so it is loading. Yeah, this is the title, whatever we have written here. Okay, so like that we can you can say start our Streamlit. Okay, now we'll be creating this web app. Okay, and we'll be like yeah, finish our project. Okay, so first of all yeah, you can say first of all we'll be create you can say uh, okay, so user input image section here. Okay, so that user can like easily, you can say import any kinds of, you can upload any kinds of images. Okay, so the good way of this using this you can say Streamlit is like already some of the, you can say, function has written. Okay, so you don't have to create, just you will call just function. Okay, so it will automatically do the work. So I will be create just one variable called upload image. Okay, so upload image, and in the upload image I will be write st dot you can say file uploader. Okay, file uploader, so it will like upload your file. Okay, so by using you can upload, so I will just write choose an image. Okay, choose an image. Then if I so it will save the image. Okay, in this binary, you can save data. Now I have to you can save these images. Okay, save the images in my you can say this upload folder. Okay, in my artifacts folder, so that I can use that. Okay, so for that I will first of all check if upload image, okay, is not none. Okay, if it is not none, like if it has the images. Okay, so then what we need to do, we will save the images. First of all, save the image. Okay, so for saving the image I will write if save uh, upload image. Okay, so this is the function I'll be creating. As of now I haven't created. So upload, so it will take just your uploaded images. Okay, this data upload, um, so this is the variable it will take, and it will return if it is getting this you can see image. Okay, so it will return true, otherwise it will return false. Okay, so I'll be creating this, you can say save upload image function here. So here I'll be creating, so define save upload image. So it will take you can say this upload image. So here I need to mention also save upload image. Okay, so upload image, this is the function, and first of all what it will do, it will just perform try, and then it will create the directory. Okay, so it will create the, you can see this upload directory here. Okay, so root directory dirs. I will pass the list here. Okay, so it will just upload path. There is, I think, yeah, we have mentioned here, so I'll just pass it. So it will create the directory itself, and now it will open that with pen, and I will just define the path with dot path dot join, and I will just, you can say, upload so in this upload path directory. Okay, so I'll be taking the image name also. Okay, so upload image. Okay, upload image. So in this upload image there is a function attribute called name. Okay, so if you write that, so it will take the name of this this images, okay, automatically. Then I will be saving uh, mm, write binary mode, and as if, okay, sorry, then f dot write upload image dot get buffer. Okay, so by using this get buffer we'll be saving the images, okay, here. And I will be returning if it is like done successfully, then I will return true. Otherwise in the except block I'll be return false. So if it is done, so we'll also load this image. Okay, so load image, because from the folder itself we'll load the image. Okay, then we'll display the image also. Display image because I am using this PIL here. Okay, so in the PIL there is a you can say function called image, so you can use that. Open this uploaded image. Okay, so we'll be opening. So here I have to write is instead of in. Okay, so if I run it right now, so if I run it, so see, this is the, you can say, uploader, image uploader, okay, option. So if you select any image, okay, suppose in the sample itself I am going to select an image. Okay, suppose I'm going to select this image, and if you now open up, okay, in your code here, so you will see it has saved these images in the upload folder. Okay, so this function we have written right now. Okay, yes. Now what we will do, we have the images, okay, right now. Then from the image itself, now we'll be extracting the feature. Okay, extract feature. So we'll be create another function, you can see here, called extract feature. Okay, so extract underscore feature. Then we'll be passing this you can see image path here. Okay, so then west dot, you can say, path dot join this upload image path. We'll giving this upload path. Okay, and also we'll be giving this image name here also. So upload image dot name, we'll be extracting the name, and also we'll be giving you can say the model here. We'll be creating the model here also. Then detector. Okay, detector means like we'll be giving this, you can say, empty CNN here, so that like it can also extract detect the face from the image itself. Okay, so that's why. So whatever I have told, okay, I will be explaining. Okay, so let me explain. First of all, suppose this is the image. Okay, so if I open up, suppose yeah, suppose this is the image. Okay, I have. So you can see we are using this, we are using just face here. Okay, but user might input any kinds of images here. Okay, so first of all we need to, you can say, detect the face, and we need to, you can say, extract the face from the images first of all. Okay, then we'll be performing all the, you can say, necessary stuff whatever we have explained till now. Okay, so that's why we'll be using this empty CNN here. Okay, so by using empty CNN we can, you can say, detect the face as I have already explained. Okay, so that's why first of all let me write here only, uh, here. Okay, I will be writing, you can say, first of all I will be mention the detector, uh, detect detector detector was like empty CNN. Okay, I have already imported empty CNN, so it will do the job. Then I will be defining my model here. Okay, so yeah, model, actually model we have already defined, so I will just copy paste from here only. So yes, this is the model I have defined. I'll just copy that and paste it over there. Okay, so yes, this is the same model we are doing, and we'll also load this, you can say, feature list and the file name also. Okay, so feature list, you can say, we are already reading here. So feature list, yeah, the file name, that one, because we have saved it, okay, in the pickle format, so we'll be like reading that. Also we'll be reading the feature list from the feature itself, feature list. Okay, so let me write it, feature underscore list pickle load open. I'll be pickle file feature list feature name. Okay, so I will pass this feature name here, and here I am going to pass this pickle file instead of this pickle file name. Yeah, so I think I can right now, so I will mention it also, what format. Okay, so read binary mode. Okay, I have already defined. So yes, we have done this, you can say, models. Okay, uh, let me define it, model. Okay, so we have done this model and our this detector. Okay, and we are also loading this file name and our feature list. Okay, now we'll be creating our second function, which is extracted feature. Okay, and so we'll be creating that. So extracted feature, will be create that, you can say, function here. So this is the function we'll be creating here. So define extracted feature. So it will take three things. One is the, you can say, image path, and second is the model, and the third is the detector. Okay, it will take three things. So here I think you have seen. Okay, actually guys, here we have done a little mistake. Okay, so here we have to mention bracket, because here we are just giving the path. Okay, so path, then we are giving the model and the detector. Okay, so I think you got the idea. Now it's fine. Okay, it is taking three argument, and now what we will do, first of all we'll read the images. Okay, by using cv2 dot I am read. this is the function I can use. Then I will pass this image path, okay. And if I want to detect the face, okay, so I will just write result then detector dot, you can say, detect face, detect underscore face, okay, detect face. Then I will just you can say there will be a equal, then I will just pass the images, okay. So first of all, OpenCV will read the images, okay. Then it will be converted to NP, you can say numpy array, okay. Then I will be pass this numpy array to this detector, okay. It will detect the face, okay. So after detecting face, it will give you can say three coordinate, okay. But boundary box coordinate, I think I have already shown you in the GitHub itself, okay. So it will create a bounding box on top of your face and it will send it, okay. So I will just you can say just keep it, okay. This four, you can say four value. So this x and y and this width and the height, okay. Then I will just extract it results, okay. So results, so this is the results, okay. In the results itself, it would be, you can say it would be a list, okay. From the list itself, like I will be extracting the first, you can say value. And in the first value there is inside it would be a dictionary, okay. In the dictionary I'll be just keep this box is a box key, you can say, okay. In this box there would be four coordinate, okay, of our face bounding box, okay. So I have extract that. Now I want to just, you can say keep just the face here, okay. So from that, like from the image itself, I'll only keep the face, okay, instead of a whole body. So I will just write y dash y plus height, then comma x clone x plus width width, width, okay. So if I write that, so it will extract the face, okay. So I have the face right now, okay, and the face itself, now I'm going to extract the feature, okay. So for that, like I will keep a comment here. So extract feature, okay. So first of all I will just you can say uh, first of all I will convert it to image, okay. So for that I will write image, then image, then I will write from array, then I will pass the face here. So it will convert it to this image, okay. Then I will just write image, and I will just resize that, okay, with respect to our you can say model image dot resize. I'll just resize it to, you can say 224, okay. So because this is the required, and after that I will just you can say again convert it to the array, okay, numpy array. So face underscore array, and I will convert it. So I'll write np dot as array. So I will pass it the image only, okay. So yes, it will convert this image to the array again. Then I will just convert it to the float 32, okay, because it might give me some error if I don't do that. So I will just convert it to the float value. So the face array as type float 32. I am converting to float 32. Then I will just expand, you can say expand the dimension, because why I'm expanding dimension I think you have already seen. So for that I will use the same, you can say this code here. Okay, this code I'll be using, this line of code I'll be copy, then I'll be paste it over there. So I'm expanding the you can say image array, this face array with this batch size. Then I'm pre-processing that, okay, this expanded images. Then here I have to write, and then I'm you can say passing this pre-processing image to my model, and my model is giving the results. Okay, so whatever we have implemented, so we are just writing the same line of code, so it will just return the results, return results. Okay, so yes, we have created our, you can say, feature extractor function here. Whenever we are getting this you can say extracted feature, so we'll storing into a feature variable, features. Okay, features variable, and now what we will do, we'll just recommend that. Okay, recommend means we'll just, you can say, measure the cosine similarity, okay, between this new images with respect to these old images. Okay, recommend recommend, I guess. Okay, so now we'll be recommending. So for that I will be create you can say another function which is recommend recommend. Okay, and this function will take our feature list, our whole feature list. Okay, so whatever we have you can say saved, and it will also take our new feature. Okay, I mean this user input feature, it will also take that, and it will just verify that. Okay, whether like you can say, okay, so it's a function. Okay, so it will just measuring the cosine similarity between these two vectors. Okay, then it will give me, you can say, an index position. Okay, index pos it will give me. So by using this index position, like I will be, you can say, display the images. Okay, so first of all I need to create this recommended folder. Okay, a recommended function, so I'll just copy that, and I will create it here only. So define recommended, it will take two things, feature list and the feature. I will create I'll create an empty list here, similarity, called similarity. Here I will be like storing all the similarity. Okay, I'm getting. Now what I'm going to do, okay, I'm going to just I will be passing all the feature list, okay, and these features, okay, in our cosine similarity function, and it will you can say measure all the you can say similarity between them. Okay, so for that I'm going to perform a for loop here. So for I in range, then len of this, you can say, feature list, and I will just call this similarity here, this similarity, and I'll be appending all the similarity. Okay, between these two vectors. Okay, similarity dot append, and I'll be passing this cosine similarity, and in this cosine similarity I'll be passing my feature, this feature, and it takes you can say 2D array. Okay, so that's why I will reshape it to 2D. So reshape it to 1 comma minus 1, so it will become 2D 2D list, so you can say 2D array. Then I will pass the feature list here, feature list. In the feature list I will pass I, because it will be going through all the, you can say through all the data, okay, all the images. That's why I'm passing the, you can say, I. Then I will reshape it also, you can say 1 comma minus 1, okay, because I'm you can say define it into 2D array. Then what I need to do, then it will you can say give me an, you can say 2D array. Okay, so from that I will extract the, you can say similarity score. Okay, so I will be like indexing. Okay, I'm indexing through the list, you can say. Okay, I'm just extracting the actual value instead of this list only. Okay, so this is the meaning of this line. And okay, this is it would be I. Now I think it's good, huh? So now I have got my similarity score here. Okay, now I'll be sorted. Okay, based on this, you can say a higher similarity. Okay, so which similarity is more higher, we'll select that. You can say that feature, that image. Okay, for our recommendation. Okay, but there is a problem. If you sort that, so it will like it will just it will also sort the index also. Okay, so we don't want that, because in our feature list there are, you can say, some yeah, sorted index. So we'll be like keeping the similar index here only. Okay, so for that, like I'll be performing the enumerating here. Okay, so for that, like I will just write index position, and then I will perform the sorted operation here, sorted, and I'll be just write it. I'll just convert it to the list, and I'll perform the enumerate here. uh, enumerate based I will just perform enumerate here on this similarity. Okay, so I think you know the enumerate. So enumerate means like suppose this is the value. Okay, I have got, suppose this is value 284. Okay, this is the value. So enumerate, what it will do, it will just you can say create an index here. Okay, only. So suppose it would be 1. Okay, and suppose I have another value 321. Okay, so it will be like 2. Okay, so it is just, you can say, adding the index here only. Okay, so it is not doing anything, because we are keeping our index. Okay, same, because if we sort that, so it will be sorting, but our index might be changed. So that's why we are keeping the index same by using the enumerate function here. Okay, so if you want to like explore more, you can run that. Okay, and you can see what is generating. But due to the shortage of time, I will just explain. I will just give you the highly of observation. Okay, so you can go through that. Then I will just do reverse is equal to true here. Okay, reverse is equal to true. And here another things, like here it will sort just if you run that, it will sort based on the, you can say, index only. Okay, so but we want it will be sorting based on our similarity value. Okay, because where this similarity score is more high, we'll be selecting that image. Okay, so that, you can say, data in our you can say recommendation. Okay, so that's why we'll be performing on top of this cosine similarity, you can say, based on this cosine similarity score. Okay, so we'll be sorted that, not on this index position. Okay, so for that, like I will write one line of code. So that would be key is equal to, I will just write lambda x I will just define that, and I will just put it 1 here, because it will just take the 1 number position, okay, because it will give you a list here, okay, and I am just keeping the 1 number position, that is our cosine similarity score, and I will just extract the value instead of the array, okay. So this is the meaning of this line, okay. So I have the index position now, so I'll just return this index position, return uh, this index position, okay, because we got our index position. So yes, we have also, you can say, defined our recommendation function here. Now what we need to do, now we have our index position. Now we'll be just extracting the name of the uh, you can say actors, or you can say the name of the man, okay, from our folder itself. For that, like, we'll write you can say predictor actor, okay. So I will be just defining an empty string here, then I will join, then I will just pass this file name, and into this file name I will just also pass this our index position only, because it will take that index, okay, which is similar to this, you can say, predicted one, okay. Then I will just, you can say, after getting that file name, I will just split it, split that, you can say, with this backward slash, because if you see in the Windows itself, it would be backward slash if you open up any kinds of, you can say, file location, okay. And I will just take 1 number, you can say, position from this list, and I will split it again, okay, split it again by the line of underscore, okay. So if you open up this folder, this data, okay, so if you see that, so it is like giving the it is just separated with the underscore, okay. So I'm just you can say ignoring this underscore here, so that's why I'm just displaying, and I'm keeping the list here only, okay. So now I have this, you can say, actor name also, okay. Now I will just display that. So for displaying, just I will just write display, and in this streamlit you have, to write 2 line here. So column 1 and column 2 dot st dot column, here you have to mention 2, because I want 2 columns here, okay. Because I have already shown there would be your uploaded image and there would be your predicted image, okay. So that's why now I will just write with call 1 and st dot header. I will mention the header here. So here I will mention your uploaded image, uploaded image, and here I will just write st dot image. I will just display the image, okay. So that's why display image, and after displaying the image, this is for column 1, and for column 2 I'll just write with column 2. I will do the similar things, but I will just write it in a different way. St dot header, uh, your uploaded, no, not your uploaded. So I'll just write seems like, then I will just adding this, you can say, predicted actor here, Okay, so it will just take the predicted actor name. Then I will just showcase the image here. So st dot you can say image, then file name. Then I will just you can say take this index position. Then I'll be just defining the I can say width of the images, because it is very small. So I just want to keep it big so that like user can see that properly. 300 300 is fine, I guess. Okay, let me see. Otherwise, like, we can change that. So yes, almost we have done. Okay, so now let's run, okay, our folder here. So I will just refresh that. So now if I browse any image here, okay, suppose I'm going to give that image, she's look like Priyanka Chopra. Okay, let's see what it can do or not. So it is giving me an error. Okay, so let me check. Okay guys, so here we need to mention close the bracket, because we're doing it in a different. Okay, then it's fine, I guess. Okay, then I need to uh, yeah, cut that one. Now I think that is fine. Now let's run. So I'm going to select the same image, and let's see. So you can see guys, it is predicting right. Okay, so it is working. Okay, so we have developed for the entire projects. Okay, see, I have uploaded this girl's image here, and she's look like, you can say, almost Priyanka Chopra, and it is all predicting. So let's see another image. So I'll be giving you can say this fake Salman Khan. Okay, so let's see what it predicts. So you can see, yeah, it is also predicting it is Salman Khan. Okay, so I'm extracting the name here. So if you have already seen, okay, I'm extracting the name this from this folder here, and it is predicting correct. Let's give another image. Okay, so let's give my image here. Okay, so what it predicts, let's see. So guys, yes, I'm looking like Ritesh Deshmukh. Okay, so I don't know I'm looking like or not. Okay, but it's great. Okay, it's predicting. Let's give Krish sir photo. Okay, let's see what it predicts. So guys, you can see Krish sir is looking like Amir Khan. uh that is great. Okay, so yeah, so this was all about this projects. Okay, I think you all have understood, and I think you all have you can say interest, okay, from these projects. Okay, so you can easily, like, by using this cosine similarity and this face detection, like, you can build an entire this, you can say, app. Okay, like which is you have already seen in the, you can say, in the mobile application, or the, you can say, over the internet. Okay, from the Facebook itself, you will see sometimes it will recommend. Okay, so just upload your photo, then we'll predict like to whom your face is matched. Okay, so that kinds of app, I think you have seen. Okay, now we have implemented that. I think this is great. Okay, and and here I will just do one thing. Okay, because we have created our stage 1 and stage 2. Okay, but suppose you are changing your data, so like, so at that time, so you can just, you can say, you can just run one, you can say, folder. Okay, and it will do your job. Okay, so I will just create that one also. So for that, just I will just create another file here. So that is touch, uh, in our root directory itself, touch.py, run.py. So if I open up that, so I will just import ways here. Okay, and I will just create a function called execute underscore system. Then I'll be write some bash command here. So let's say bash one command. I'll be writing Python. From the src itself, uh, we'll be running this uh, you can say our first stage, okay, which is you can say generate underscore image underscore pkl dot py. So this is one file we have to just run, and the second file I will just copy that, and I will just change this to bash 2. Then same, I will just change it to 2 because this is our twin stage. Then I will just write it feature extractor dot py. Okay, feature extractor dot py. Yeah, feature extractor dot py. So these are the two files I have to execute whenever I'm changing the data. Okay, so now I'll just write west dot system, and I will just pass this bash one command. Then similar wise I will just do that west dot system, and I will just pass it bash to command. Okay, then I will just you can say print here executed successfully. Okay, now I will just keep it in the if name underscore name, and I'll just calling my function, and it will do the job. Okay, so this run.py, when you need to just run, okay, suppose you have suppose I have 100, you can say you can say Bollywood celebrity images right now. Suppose future you might have lots of images more than 100. At the time you can also improve that model by adding more number of images. Okay, at the time whenever you are I mean giving the data, okay, you are updating the data here, just first you have to run this run.py first of all. Then what it will do, it will generate the same embedding.pkl and image pkl file here. Okay, then you will run this you can say app.py. Okay, so app.py, and whenever you are running this app.py, then you will be starting you can say predicting on top of your new images. Okay, so the command is to run this you can say app.py is like streamlit run app.py. Okay, so this is the command you need to run. So yeah, by using that you can like we can like easily start we can say predicting on top of your images. Okay, so yeah, this was the whole you can say process of this project. Okay, so you can deploy it in any other cloud platform. Okay, so that you can share the link also with your friends. Okay, and you can have fun, but as of now I'm just leaving it. Okay, if you can do that, just you can do that. Okay, because this video has been already long. So yes guys, so this was all about from my side, and I think you have enjoyed a lot. So guys, as you have already seen the implementation of this projects. Okay, so if you like this video, if you like this project, so just do share with your friends. Okay, and yes, that's how you can easily implement I mean many kinds of solution. Okay, so if you have the idea, so you can implement. Actually deep learning is like it's an interesting thing. Okay, so you can create you can do very interesting kinds of thing with this deep learning stuff. Okay, so thank you so much guys for watching this video. Just do comment below. Okay, so how did you enjoy, and I will see you next time.